We are gathered here today to discuss C language. My idea is that Ginger Bill here made Odin language because he hated C. And he didn't want to write C, okay? No, that's my mental model. I cannot break this right now, okay? And Ryan Fleury is working in Rant debugger, and he changed from C++ to C to be even cooler. 40% speed up. Oh my god. Get rid of C++ bull. And I shouldn't say bull. You can't say swear words, especially in the beginning of the video. So, we're gonna have a C debate, programming language debate. It's not gonna be much of a debate. I will just ask questions and let you talk, okay?
Okay.
I think that we'll find a lot of disagreement. Despite everybody saying that you all agree, okay? And this is what I'm hyped for. The more disagreement, the more entertainment, the more clicks and views, and we're all about clicks and views, okay?
Okay.
Do you want to say a couple of words about yourself before we kick this off?
You can go, Bill.
Okay, thank you. Yeah, sure. My name's Bill, Ginger Bill, most people know me by. And I am the creator of the Odin programming language, and I work at Django FX, working on numerous fab real-time products known as Embergen, Liquigen, Geogen, and now Illugen. So it's quite a bit mouthful, and all of those products are also written in Odin as well. So battle tested already, put it that way.
Made a language, and
Yes.
now company is using this language,
Yes.
making products in the language and making money. How many people can say that? How many people
Not
can
many.
say that?
I can't even believe I'm saying that. It's a bit of a surreal experience every day. It's fun. I love it.
Ryan.
Well, so the first question I have, I want to ask a quick question really quick. Are you going to be are you going to be like the programming Jerry Springer? Is that what you mean? Like you're like, look, we've got to have fights and controversy. So this is going to be Wookash Springer
Jerry,
I don't know.
Jerry.
I don't know the reference. Is it American reference?
Yeah, it's just I mean, I didn't even really watch it. I think it was before my time, but my
It's
understanding
before
is
my
like,
time as well.
yeah, it's just insane, ridiculous show where people go on and like they sign a contract and they're able to physically fight. I think, and then like I think stuff like that happen. I don't know for sure though.
No, we should do a second edition in person, and then we're gonna do a proper one. Thanks for the idea.
Great. Okay, you're welcome. So my name is Ryan Fleury. I work full time on the Rad debugger. Before and Rad debugger, just graphical native program debugger. Currently on Windows. Currently in the process of being ported to Linux. Before the debugger, I've spent most of my life working on games and engines and stuff since I was a kid. That's primarily what I work on. I cannot say I've made a language that has been used in successful products. So Phil's got me beat there. But yeah, I program primarily in C. I grew up when I started. I did a little bit of QBasic, then Visual Basic. Started doing C++ for game engine and game programming around like when I was like 10 or 11. Like Bill, I found Handmade Hero. Learned that there was a bunch of nonsense in my way, and then just kind of stripped away layers, and then at some point I came to the conclusion of like, C, I feel like I can get what I need to done in C, at least for now. It's not that I like it particularly, it's not that I think it's the best thing ever, but it's at some point I just came to that, I guess. So yeah, I do most of my programming in C today, and that's where we're at, I guess. So the Rad debugger, I moved it. I did move it from C++ to C, although I will say it was mostly C to begin with. It was like Casey style C++, really, the code base when I kind of took it over. So there were like 5 things I had to change. I mean, 5 things throughout the entire code base, like patterns that use destructors, for example, but it was mostly C already, but that's how that happened. I didn't exactly go and rewrite everything to use like no C++ constructs or anything, like, because it mostly just didn't already.
You sound like you're explaining yourself, like you're put on the spot. It's like, what did you do? It's like, no,
it was just a little bit. It was just a little bit. I didn't. Yeah, exactly.
Hey, don't feel I've been in that same situation. Like the Odin compiler was originally in C, then I moved to C++, then back to C, and now I'm back to C++ again. Like that's how C like my style is in general. Like I could have able to do that. Now it's kind of I couldn't do that anymore because of how old the code base is. But yeah, don't need much from C++.
Yeah, because you still use like I knew that you had like a defer construct in C++.
Yes.
I assume you make use of that in the Odin compiler.
Yeah, so defer construct is one of the things. I have effectively custom string types and custom array types, so you can have the indexing on them effectively with bounds checking. And I have a type safe hash map, which is not always easy to do in C. And also default values on argument like procedure parameters. That's about it. That's pretty much my C++ use.
Yeah, that makes sense.
Let me interject here for a moment. What you are referring to as Wookash Podcast is having its own private Discord server where members and guests of the show can chat together. On top of that, members can know in advance who's gonna be on the show and can submit questions beforehand. Go to wookashpodcast.com to learn more. Now, I am hyped about you both being quite young. I'm not gonna disclose your age, but starts with the digit number 2.
Mine does.
Mine doesn't anymore.
Ah.
Oh, damn it. Damn it. Let's end the show. End the show right now. Okay. But anyway, you're very close in terms of age. And you're not one of the... If you were to have like 40 years of experience in C, it would be a kind of different debate, in my opinion. So this is why I'm excited about this, because you are quite young, but you have a lot of experience already. And this is why I wanted to ask you, like, what do you like and dislike about C, basically?
Okay.
So, first question. And in my mind, it's gonna be Ginger Bill, who made Odin, who hates C, it's gonna trash C, and then Ryan was gonna defend C, okay, because he loves C. This is my mind, okay? So, imagine there's somebody who wants to start programming, wants to pick a language, looked around, done some Python, maybe JavaScript, something like that. Just like it knows how to do stuff. There's line to line, write a line of code, and then something happens. We're already done, okay? Now, would you introduce C as a primary language for this person, like an introductory language that you're gonna learn the programming with this? Bill.
So luckily, thank you said they, how do I put this? Already know some of the languages, like tried other Python and such. Because if you said it was the very first language, my first result would be they need something else. Don't start moving with them. I've now been thinking maybe some sort of like very basic assembly language. But now they've got this experience, so C would probably be a very good option actually to teach them. I know many people have been telling me maybe Odin's even better because it does break out the constructs better. Like, oh, you haven't got like a pointer demotion anywhere as well. So it's probably easier to understand. But I still kind of recommend C because so much code is written in it. You'll be dealing with it all the time. So it's probably a very good idea to learn it. The problem with learning C is most resources on it are also bad. And learning how to write good C is hard. And there's not much out there, unfortunately, for that.
So you would say that, because I didn't understand the answer. Would you recommend it or not as a like
most
a
likely yes.
Okay. So you think that somebody should go through this journey?
If they've already gone through like Python and JavaScript and all that lot, they've already done those sort of languages, then yes. I would never start anyone off with C though. I think that's probably a very bad idea. I don't think it's anyone's real first language ever. So
it was mine in university, but okay. Like it was weird, but
I'm so sorry.
Okay.
Sorry.
I thought this is normal practice to do like this, but okay.
Well, my first language was Game Maker language, which was that's an experience.
Okay, Ryan, what do you think about this introductory language?
It's kind of interesting. So I think that one of the reasons why I would pick C at all today is because it's basically for the long-term building of a code base where there's been a ton of investment into the tool chain, so that I know that there's tons of money on the line in a working C tool chain, so I can sort of be a little bit more guaranteed for a very long term in working on a C code base that I can build with a C tool chain. So it's almost flipped for me. I think Odin's design matches my intuition of how you'd want to do it, like much better than anytime I look at any of the new languages. Odin is just like very well designed by comparison. So there you go. Yeah.
Thank you.
So yeah, every discussion I've had with Bill in the past, it's like when he breaks down why he's made certain decisions, I'm like, that makes perfect sense to me. And he has a similar aesthetic idea for like, how do you make something simpler, rather than C like blurs the lines a lot. There's a lot of complications. Like, I feel like Odin more directly communicates ideas like pointers and like those concepts are cleanly broken apart. The idea of type operators, it's not this strange syntactic presentation of like basic language constructs, basically, which C has sort of just had the whole time. And so I feel like if someone was sitting down and they're like, okay, I've done Python, I've done JavaScript, and now I really want to learn about how pointers work at a very basic level, and I want to learn about like a more native programming style like type system, I think there's less nonsense in the way in Odin for them to learn those constructs. Now, the equation for me would so I would say if they're just trying to learn, Odin would be a great option for them in my head, because it's like, no, it's actually cleaned up language design. Like, they would actually probably learn the concepts more quickly. I would agree with Bill, though, that long term it's important to have some familiarity with the rough edges of C, as annoying as they may be, because like he said, there's so much code written in it. There's so much of it that's just baked into the ecosystem at this point that you have to be sort of prepared to deal with it and read code either written in C or C derivative languages. And so, and then, like I said, when it comes to building long-term code bases, you really want to be at a stage as a programmer where you don't have to feel like you're locked into a particular language. Like, you just want to pick a tool chain based on what you think almost economically it'll mean for you long term for your code base and for your project and company and everything. So that's, I guess that's my answer. It's almost flipped. I would say, like, starting with Odin is maybe better because it's just a cleaned up language, but at some point you've got to learn it. So I don't know. I'm jumping around a lot there, but hopefully.
No,
that makes
I agree
sense.
with you, Ryan. That's the problem. We're not debating here, kind of thing. It's kind
Damn
of,
it!
It's
Damn it!
The other issue is also, if you did learn Odin, you're like, I'm sorry, Wookash, but the problem here is just more of a. It's not just if you know Odin, right? If you say you learn Odin, a lot of the choices and decisions in it may not make sense unless you know C as well. Like, why was it this done this way? It's like, oh, it's a bit different to my other languages I've used. But if you came from C, you'd be like, oh, I understand exactly why that's done. Right?
Yeah.
So it's kind of more of a, and again, I'm technically a programming polyglot at this point. I know literally dozens, if not hundreds, of languages, and it's you kind of have to just use the right tool for the right job, which means you need to know the alternatives. As many people now know on the internet, they think the right tool for that job is JavaScript for everything, right? They always think that. But they do. But she's like, no, that means you only know one tool, which means it's the worst and the best tool possible. Which is never a good sign.
So let me summarize that. People should, at some point, learn C, because the ecosystem is so big and the long-term value of the program in C is bigger than in other languages. But it's not necessarily a good language to start with when you're trying to learn about memory management, pointer, semantics, and all that stuff. Is this a good summary? None of you look, please. None of you look.
Yeah, like I think C makes certain things implicit, and a beginner won't catch those things. Like, they won't know how types are being like decaying. Like, arrays will decay into pointers. There's integer promotion rules. Like, there's all sorts of implicit things that are happening. Languages that go and make those things more explicit and make the type operator syntax like more obvious. Like, I programmed for C in years before I really understood how a type graph looks like in a compiler, like what a compiler would actually form. Like, what does the data structure look like to represent the idea of like a pointer to an array to pointers to structures of like, forming that kind of graph in my head, that's not how I really thought about it before I kind of, but Odin's syntax is literally that explicitly. It's like, look, here's the chain of type operators you have in a row, and C obfuscates that, I guess. So,
well, it's because Odin, I'm taking the idea from Pascal. Literally, Pascal was like, the types are on the left, the usage is on the right. So it's like, you've got the caret for the pointer, and then use and then to do references, use it on the right.
Yeah.
C had this idea, if you go back to history, C's declaration syntax reflects its usage.
Right.
Which was an idea that they had. No other language has ever copied this, by the way, unless you class C++. It's kind of actually a failure of an idea.
Yeah.
But unfortunately, C became so popular for loads of reasons, we're stuck with it, like only in C. Everybody else just didn't do it anymore after that reason.
Can you emphasize what was the bad idea?
The bad idea is in C, the declaration syntax reflects its usage. So that's why if you see the pointers, the way you use that value looks the same as where you declare it.
Yeah.
And it's really weird. Once you understand that rule, you go, oh, everything makes more sense to read. And then you go, that's a crazy rule.
Yeah. Definitely.
All right. Okay. So, no blood at first question. We're gonna move to the second one. What would you recommend C for? Like, what type of project? And where the C will fall flat? Ryan now, maybe first.
So I think if I were starting a new code base today, the reason why I would pick C is because I don't expect to write a lot of code that I will, or let me put it this way. It's not that I won't throw away a lot of the code I write, but it's that in this code base, if I expect this code base to evolve and propagate for the next 10 plus years, I'd get very nervous about doing that in a language with less investment on the tool chain, if that makes sense. So if I were starting a code base for a company or something, like where it's like going to be long running products or something, or a game engine, or like very long running things that I've got to worry about. Now in Django FX's case, it's sort of a special case because it's like, they have the creator and owner of the
initially they didn't initially. I've been working there now 5.5 years now, but the company's been around for 6.5.
Yeah.
So
now if you have the opportunity to hire the guy who's building the language, I mean that's a good move on their part.
That's a special case. That's an exception.
Yeah, because I think if you can't do that, then it gets sketchier. Like if you couldn't have because you have to rely on code that your employees write anyways. Like you have to have trust, and you have to rely on what they write for a very long time. If that includes a programming language, and if it helps you, that's great. Now, if I was starting a company where I do not have either the money or the personnel to like maintain a language for me, I'd be a little bit more nervous about it. And the fact that C has lasted for so long, there's so much code in it that cannot break, that people are not actively maintaining. It makes it a relatively more solid ground for long-term code bases in my head. So that's why I would pick it. The other thing that I would say about it is that people think of C as a very particular language. Bill said correctly that like a lot of the educational materials on C do not teach you how to write good C. In my experience, once you understand how to build a good code base in C, it becomes much more viable as a daily driver language, because you can make things very comfortable. Even though, maybe the syntax is janky, things aren't quite as succinct syntactically as you might imagine. In practice, I'm not sure how much that slows me down. I'm sure it's not zero, to be clear. Like, I don't think that syntax is unimportant, but I just think that when you do the whole analysis, it's you can make it relatively comfortable enough, and the fact that there's so much investment in the tool chain sort of gears it more towards that like long running code base thing. Now it's sort of a circular thing, right? It's like if people are building all these long-term code bases in C, there's no path to language improvement, right? To some degree. And so at some point somebody's got to make the jump. And so that's a separate discussion. We'll probably get into that later, but that's what I would say for that question.
So I'd like to summarize this so that I understand where you're at.
Sorry, I'm all over the place, but
Yeah, you've got the two most rambling people possible. Here we go. Yeah,
Yep.
Even I can't get it out.
So to summarize this, you kind of view this from the lens of your company and where you're gonna be at for the long term, and especially for the long term project. C makes sense. Does it also imply that for side projects, but also like game engine from scratch, but like side project wise, does it make sense to use C or just head straight to other alternatives like Odin?
I would say it depends on how transient you expect your code to be, or how much weight you want to put on, like, do you really believe in like the Odin project? Do you want to rely on it long term? That's a decision you can make. Obviously it's lasted for 9 years at this point, right? It's like, the longer it goes on, the more likely it is that it's a viable option long term. So
what, Lindy law, Lindy effect, Pareto distribution kind of thing. Yeah. But no, it's to carry on from this question in general. I clearly made C because I wanted something to work on. Short answer is I just didn't want to deal with C. Right? I'll try and keep the question to itself. But the point about tooling is very good. Like this is the problem, is if you're going to make something, you want it to be stable, you want to have all the tooling you can get so you can get off the rails very, very quickly. And C has all of this tooling around it. However, and I will state this in a weird sense, like when I started Odin, C has a lot of tooling, but it also has a lot of bad tooling. A very good example of this is, again, Ryan's made the RAD debugger, and it's coming to Linux soon, from what he's just told me. And great, so that will be the best thing on Linux, the best thing that happened to Linux development for the past, 20 years. Because this is the funny thing about people worried about all this tooling, and they don't even do it even for the current languages, let alone the newer ones. And I think that's also kind of half of the problem, where you have to understand, like, okay, what is the current tool set that you've got? And at least with, like, when I was like doing Odin, I could start creating my own tool chain on top of it or alongside it to help everything go along, as well as adding things that I would have had to augment anyway with like C. Like, for instance, Ryan has his own metaprogramming stuff, the Metadesk thing, whatever you're calling it nowadays. And that will generate the C code because you're finding out the lacks in the language. You want to add some more stuff. Well, I put a lot of that stuff into Odin itself already, like the stuff that you'd be saying. So it's kind of very much like, which path are you going to do? You're still going to have to write some of your own tooling, unfortunately, if you're going to be on this project for a decade at least. So it's this question of, is C a good choice? And the answer is maybe. I'm sorry, I'm always it depends. You have to, it's on a case-by-case basis. I don't give generalities ever.
Okay. But we're very, very heavily focused on building the businesses that will last for 10 years. What about all the other projects? Like smaller projects for yourself, maybe some experiments.
Okay, so if it's small projects, if I want portability, then I would use C, right? I want it to be able to run on everything, which I could do. But if it's Odin, like for me at the moment, Odin's really only caring about certain platforms because they're the only ones I really care about at the moment. Now, if people want to support more, that's great. But for me, I'm clearly doing everything in Odin now. Like, that's every single project I now start is an Odin project, pretty much. It's very rare I'll do a C project now. But I am the creator of my own language with my own tastes and clearly put them in there. So it'd be surprises if I didn't.
Okay. So, to wrap up, again, to summarize, I think if you have a long-term view, if you start a company, if you want to have tooling and tool chain that is sensible, C seems like a strong option. For the other smaller projects that you don't necessarily have this like high bar, you don't want to spend next 5 years doing this project, or at least it's like a half learning, half educational thing. More likely Odin. Is this what I get? I need
for
to,
me,
I need
yes.
to get
For Ryan, I bet Ryan do everything in C. That's what he would do. Sorry, whichever way you're going to put him on the king, I'm going to point at. But yes.
So is this the first place that you disagree? For smaller projects, like hobby projects that you do after hours, you would use different languages. Yes.
Well, probably because we probably do. Well, here's the thing about that, right? If you kind of imagine, like, let's take the language name out of the picture. So let's not say it's like Odin versus C. Let's say it's like, actually, Eskil Steenberg at BFC had a really good mental model for this. It's like building your kingdom or your mountain or whatever he called it. Something like that. If you imagine it's like Bill's mountain / kingdom versus Ryan's mountain / kingdom, it's like, yeah, of course, like I would pick my mountain or kingdom and Bill would pick his. His includes Odin, mine does not, but it includes all this like C code base stuff, like my metaprogram stuff, like it includes all these layers that I've built. Or like versions of it in multiple code bases, because one of these code bases that I work on is the Rad debuggers. One is my personal one. They have a lot of similar ideas, but they're not the same code base. But it's like, point is, I have these translatable ideas in that space. Whereas, like Bill has Odin, which he's put a lot of work into, like, the standard library, bindings for all these different libraries that you could have, native ports of like Odin written ports of libraries, things like that. And so it makes a lot of sense for him to pick that, because like that's his domain, like that's his code base that he's built up effectively. And so it's almost like I wouldn't expect him to pick C, really, because that's his thing that he's worked on, in the same way that I've built like my code base stuff in C. So like I've got in my code base, I've got I had to write like an HTTP thing for like a permissions system, like I just have an API for HTTP stuff and I can call it, and it's like it's more succinct than because I wrote this initially in Go, and I had like a Go program to manage these permission things for my like Substack and Discord and Gidia or whatever. It's like really simple program, but I wrote it originally in Go. I'm not a Go programmer, so it might have been very like overly verbose or whatever, but I was like, man, I really would just rather have this in my own code base. So I built my own HTTP API, and it's just a wrapper of the natively available one. So on Windows, that'd be WinHTTP. And it's like, I just built the API that is in my style, and it was really easy, and it turned out more succinct than the Go standard API. So it's like, I can just have that, and it works for me. But it's not that I think it's going to work great for everyone else. It's just like, that's my kingdom, like that's my mountain, you know what I mean? Just like Odin is Bill's, except there's a lot more people working on that one. But yeah, that's kind of the that's what I would say about that.
So you view this as also like extending and layering your own tooling, and then once you start to invest in some language or some specific aspect of it, you kind of have this already, so why not use it, why not extend it, and you kind of like make this bigger mountain / kingdom of your own stuff, which kind of ties you to what you have chosen in the beginning.
Yeah, I don't think you can really get away from the history of a code base or project, really. Like if someone's starting today and they're like, I want to have a really good out of the box library experience, and I just want to get graphics on the screen really quickly, no questions at all, Odin's going to be way better for that. Like, just absolutely no question at all. Like, the C library...
literally download it, you're done.
Yeah, like, it's so much better. In C, it's, like, got this bizarre build model. You have to textually include header files and then link with the, binaries, or, like, hope it's simpler than that. But that's like, sort of the... unless you're getting a single header, that's kind of the best case scenario in C. And it's, like... It's just this whole nightmare to actually get up and running in C if you don't have a code base behind you. Once you do have a code base behind you, it's like I can start a new program and get graphics on the screen in 2 minutes. Like it's not a problem because I've done the work in the past. So I can use that prior investment basically. But if someone doesn't have that, it's like Odin's going to be way better out of the box, no question.
We trailed off from the original question, but I think this is a good place to sum it up.
Okay.
Oh no, actually we didn't, but like we kind of, right. This was the category of questions picking C, okay? When to pick C and when to not to pick C.
Okay.
I think we covered it. Okay. Is everyone happy with the state of the affairs?
So far, yes, so far.
Okay. We can do a bit of a break take a look at chat. There was one interesting question during the when you were saying that, oh, Bill, who has done Odin language, is also employed at JangFX. It was like, well, what about if Bill will leave?
What if I retire? It said there, and I'm like, I am 30 years old, by the way.
Yeah.
I don't think I'm retiring for quite a long time.
Exposed the age.
Yeah, I've exposed my age at this point. I mean, like, most people think I'm much older. Even in real life, it's terrifying, actually.
It's because of the beard.
It's the beard and the balding. I know it is.
Okay, no blood. Still no blood.
No blood.
No blood.
Okay. All right. I'm getting ready for the next part. The next part is using C, and you probably have seen with the screenshot, using C has a lot of C questions in it. So now we're getting technical. So for everybody who is in the chat, strap in, okay? Now it's going to be really technical.
Here we go.
Bill, what C standard is the standard?
The one I will use is now C11. Put it that way. And that's just because of the atomics, pretty much. That's it.
Maybe we can break down a little bit, like what happens in the newer ones, like what the older ones improved, so that we kind of get the wrap.
So the C89 or C90, depending on how you want to, which organization you want to standardize on, that's the most like portable version you can get there. But that's the first standardization, like the ANSI, ISO, whatever you call it is. Then you've got the C. It's technically a mini one in between. There's a C95, which is what Visual Studio supported for a very, very long time. Then there's, but that one, no one really knows about that one. There's C99, which is the first big one. C99 introduced things like, single line comments. You can now declare variables anywhere rather than just at the top of the scope. What else did C99 bring in? A few other things. I can't remember at this moment. And VLAs, which no one ever likes or uses because they're awful. But then it came to C11. C11 was kind of copying the C++11 atomics model. So they added a way of doing generic, like a generalized form of atomics and threading and synchronization primitives and such. So that's what C11 kind of solved. Then there's the newer version C17, which was kind of revision on C11, which also deprecated VLAs. Also C11 also added the generic thing, which I never use either. I find it actually kind of useless. There's not really a case for it. And then the C23, which I think is the latest one, which has added some new features like type of, or decal type or whatever it's called, or it's now got a null pointer in there as well because reasons, and all these other different things. C23 because it's like
auto.
There's auto, auto. They replaced the meaning of auto to now mean type inference. This is why I'm saying C11's the last one for me at least.
Okay, Ryan.
I think Bill and I will agree that the newer C standards, like they're kind of not being C anymore. Like I don't really have much in common with the people who seem to be working on the C standard at this point. Like it doesn't seem like it is preserving the value of C as I understand it. But I don't use C11 probably just because MSVC does now support it, actually, so I could be using it, but for the longest time they didn't. Like, I was on 2017 for a while, and then I think I might still be on 2019 on the computer I'm streaming this from.
I think I'm still on 2019 as well, actually, but...
do they have C11?
Or am I 22? I've got both, I think.
Okay, yeah. I think...
I can't remember which one it is.
I know it's like... I know technically before they got C11 support, it was like not even technically C99, because they didn't support some two features or something, so it wasn't technically C99 support, but it was like close enough, like you could write your code...
Yeah.
You could write your code that could compile in MSVC or Clang, and it's like roughly C99.
And even then, C99 was only recently supported as well, because again, for the longest time, they were using C95, I think that's the name of it,
right,
which was like a fake substandard that didn't really exist, but except in the Visual C compiler, where effectively it was still C89, but they had single line comments.
Yeah.
Effectively.
Although you could do...
very weird standard.
You could do declare anywhere since maybe 2015 is when you start doing declare anywhere.
I can't remember when it was, but I remember probably 2015. Yeah.
Okay.
It's just one of those. So the question is which version? What I think is the correct one. my answer is, I don't know, C99 or C11 now at this point. Again, it's the newer versions. They're adding too much, all of these new stuff, and it's kind of getting away from the essence of C as well. They're wanting C to be a more modern language and do all these new features. And I'm like, great, you guys don't understand why people still use C. It's not because,
That's to me like a weird thing. Like C++ was meant to be this like crazy, all the features language in one language. Like, and for years it was like slapping or like all the stuff goes in there, like, like anything. And now when C gets these improvements, it's like, wow. I mean, why? Why is that? Do you know the people that are working in the committee? Like, why they?
Well, technically, we know one, but he's always answering no. He never votes. It's called Eskil Steenberg. He just says, he still uses C89 for goodness sake. Like, he's not even using any other version. It's just the very first one he's using. He's happy with it.
Honestly, I don't understand what Eskil is doing there on the committee. I need to ask him. We're going to have a podcast episode.
Okay, there are certain things he actually is standardizing to make them actually decent. Actually, there are certain things I think he's working on. It's just, he's not adding new features. He wants things to be defined correctly.
Okay. But it seemed like everybody in the C committee kind of should have this mentality, because like the language has this mentality, right? Like, doesn't make sense. Like,
so one of the things
they're a committee.
Ryan.
Sorry.
It's your floor. Go.
I don't know if I might have a slight delay. Also, my internet's not great, but so the thing I wanted to say about the standards thing is, like, I think a lot of people they think of like the standards almost like the government of like the C universe. Like, they're sort of like, oh, like the standards committee decides things and then everyone goes and implements it, and it's like that's how it works. And so if someone makes a decision in the standard, then it's like it just flows downwards from there. They're like this weird, like, I don't know, like unelected bureaucrat like circle up here, and they're doing like they make these decisions and then it flows downwards. But in my head, it's like, it's actually really the reverse of that. Like, I don't think, to me, what's important is who implements what. Because again, like, the important thing for me is the tool chain. And so if someone has a bunch of C compilers that do certain things, to me, the standard is whatever they happen to be doing. And if the spec goes off and does ridiculous nonsense like they're doing, it's not really that material to me, because it's like, on the ground, people have to compile C code tomorrow that was written 20 years ago, period. And they're not going to stop doing that. And so that is the standard to me. Like, that's the only standard I happen to care about. Yeah. And so whatever they keep doing is like, whatever, like the people who actually wrote the code and built the tools and actually did all that, that's where all the actual power is people who actually built stuff. So that's kind of how I feel about it. So, and that matches up with what Bill said as well. Like C11, C99, that's what people have actually done. That's where all the code is. That's what people have to build. And so, that's kind of where is like stable ground in my head.
But you said something that I didn't really understand. You said that like the standard is de facto the toolchain people and whatever the toolchain is accepting. But toolchain people will implement the new features of the new standard, right?
Okay, I can probably make the essences. There's a difference between de facto and de jure, right? Yeah. Is it the written law or the essence of it?
Right.
And this is when some people, the spec is there, that is the written law, but that doesn't mean anyone adheres to it. Right? Just because it's written down doesn't mean anyone's going to be doing it. And in fact, most compilers do things very different to actually how the spec works. So yes, those compilers compared to the written law, the de jure, is wrong. But the real world is, these are the compilers, this is what I've got to deal with. And that also includes all of the extensions as well. Because no one, and I mean virtually no one, is actually writing pure C. We are all using loads of extensions implicitly across all the different compilers. So we actually find the overlapping of all the different extensions and use all them to make things work correctly. Because if you use pure C, you'll actually hit some really like annoying things that you won't be able to do. Like a lot of like people use like built-in intrinsics, or they'll use some minor, even pragma once, for goodness sake, some people use, which is like an extension, but it's on pretty much every compiler. So you have all of these different aspects, which are, we know what the actual like real world C is. We don't really care about the spec except when we're trying to find bugs. if that makes any sense. Like, here's how one compiler's implemented it. Or we look, if you want to reference the spec, that's when we want to implement a C compiler. And then we go, okay, we've implemented the spec. Now we extend it. That's kind of the purpose of a spec, in my opinion. It's not the law. It's the... I'm trying to figure out a way. What's the better word? It's de jure, not de facto.
But it's still like if the C23 introduces the new auto keyword for type inference, at some point, people working on the toolchain will add this to the compiler, right?
Yeah. Oh, so, no, you're not wrong. It's just the question is, you still need to look for that subset and overlap with all the compilers. Like, I doubt Visual Studio is going to add C23 features anytime soon, especially since I kind of actually, I'm not going to say anything, but from what I've heard in Microsoft, let's say the Visual Studio team is not doing much now. Yeah.
Okay. So you're saying that the time that will take to actually implement this across the compilers is going to be tremendous.
Yes.
Okay.
Well, it's not even necessarily that. It might not even happen for some compilers.
Okay.
It's also, there's the C spec by design is abstract with respect to the target hardware, but everyone who actually writes C, they need to understand the target hardware. Like, you actually have to understand what the hardware is going to be doing. Nobody's writing to the abstract spec really, and like not caring about what the computer actually is doing at a lower level. But C, the whole pitch of C was like, oh, we're going to make this language where certain constructs can be portable inside of it. Obviously, not all of the code can be, because the code is so wound together with what the hardware is actually having to do. But some constructs can be standard, like, you know, if you have certain type definitions or certain very simple code, it'll translate fine. But that's the whole pitch of C, right? It's like, oh, we're going to make this spec abstract with respect to the actual underlying hardware platforms. And so, like, I'm just agreeing with Bill again, there's no, sorry. I'm sorry. But it's like, nobody's writing C because they're writing C with MSVC on x64 on Windows. Like, that's the actual thing they're writing to. That's
but Ryan,
the actual
don't you know
spec,
they're invoking undefined behavior doing that? Don't you know it's all undefined behavior?
Yeah, exactly. Yeah.
And it's not like this is where you get some of the the compiler autists at lawyers, where they'll go and like say, well, the spec says this, so therefore you're invoking undefined behavior. And I'm like, yes, I might be invoking, but the thing is, it's defined like this in this compiler, and this compiler. And I know it consistently, it will be defined this way on those compilers. But so, no, that's undefined behavior according to the spec. And I'm like, okay.
Yeah. Yeah.
All right. Which C standard RAD debugger is using?
C99. We don't use any C11 stuff, so it's just C99, or some subset of it, whatever MSVC happens to compile.
Okay. All right. On to the next question. Now it's gonna be okay. I will swap the order of the question to make it
okay
more interesting, because you just said that like C new standards, dramatic, awful, don't do anything, and so I'm gonna ask the question, starting with Ryan. What features in C do you lack?
Do I lack? Yeah, I mean, it's kind of hard to say, because the things I lack, I don't necessarily want the compiler to be doing, if that makes sense. Like Bill brought up like metaprogramming stuff, and it's like, I don't really know if I want the C compiler to be providing me compile time execution or something. It's like, I can just write a program that runs, it's fine. Like, that shouldn't be an extension to the language or something. My opinion is like, I don't really want C for more features, exactly. Like, the whole reason why I'm building my code base on C is to build my own little code base around it. It's where I can build the features I need. So I'm trying to think of a feature where I'm like, oh, if only C had that. I mean, there are cases where I'm like, type of would make this a lot simpler, for example, or or decal type or whatever it happens to be called. Or like, oh, if the compiler automatically generated like some runtime type information tables, like that would make certain tasks simpler for me because someone else would have done the work. But it's hard to say just because it's like, it's a matter of, do I want someone else behind a committee, behind some giant corporation maintaining like the MSVC compiler or whatever? Do I want them implementing this feature or do I want to be implementing this feature? And usually the answer is like, I think I would rather just do it because, you know what I mean? So,
but
I hate to avoid the question,
like,
but...
Exactly. Like you would have this feature implemented as you wish, okay, as you desire. You can be the person who's gonna implement this feature. Like,
oh man,
you don't need to like abstract this into like, oh my god, if the people that I know are gonna work on this feature, then I don't want it. Like, is there technically a feature in C language from other languages that you would use if it was there?
Yeah, I mean, you know, there probably is. I'm having trouble thinking of it.
Do you want me to give you a hint? I'm not saying it's what I want, but I could give you a hint maybe for you.
Oh,
okay, yeah. That would help.
There we go.
Yeah.
Come on. What about like slices? Like literally a pointer plus a length.
Yeah. So
just the syntax for that.
It's one of those things where it's like you could find patterns that I tend to use a lot and replace them with a more succinct syntax. I don't know. I would probably accept that. Like, it wouldn't be that bad. It's just hard to know if that's like the highest priority. I don't know, because it's like I'm just writing structs that are slices anyways in my case, so I don't know if I care like that much. I mean, the syntax would help a little bit, but it's yeah. I don't know. I'm sorry, I don't have a good answer. I feel like I'm sure I could find one if I thought about it for a long time, but there's nothing I'm like, oh, if only C had this one feature, because I can just kind of do what I need to mostly.
Like that's why I was trying to give hints. Maybe another one might be some other stuff from C++, like a default arguments to procedures and such. Like oh, this is, instead if we don't type this one, it's got a default like true or a 1, 2, 3 or something like that. I'm just trying to give ideas. I'm not saying they're correct ideas.
I tend to just do that with like with a macro, like with a struct parameter that wraps. Like, so you've got a struct pointer parameter, and then behind a macro you can you pass the struct initializer, and then you use like VA args or whatever. I mean, what's like one example? I feel like I don't have a good like concrete feature idea here, but like the variadic arguments situation seems like a mess. So that would be good to clean up, like, I guess. Again, not really a material feature I can give you.
You're either avoiding the question. You're either avoiding the question, or C is the perfect language. And
no, it's not the perfect language, because but it's perfect. It's imperfect because it has too much. Like, it tries to go too far, actually. Like, that's actually the problem. So it's not like if you added more features to C, you'd make it better. C actually needs to be rolled back. Like, it's actually trying to go too far. So it's not that C is perfect. It's just that more features wouldn't fix it, if that makes sense.
Yeah.
Removing features is what we're gonna get to. So, okay, hold your horses.
Okay.
Now, Bill.
Yes.
I've got an idea.
Oh, go. Ooh.
The build model is horrible. So you should just fix that. Like, go back to like the Turbo Pascal style builds, so where it's like, which I'm assuming is where Odin derived its like ideas for like modules and distribution. Just actually build a proper module system in C. That would probably fix a lot. Maybe.
Okay, we got one feature from Ryan. Nice. Nice. Now, Bill, technically speaking, if you say any other feature than this, or not say this feature, you disagree with Ryan. Just want to let you know before.
Okay, there we go. Perfect, yes.
So it's just going to be the first time where you disagree with Ryan. Tell me, what features in C do you lack?
Do I lack? Right, so to get the story of how even Odin came about, this is explain what I was doing. So this was going back 9 year's ago. The beginning, literally my New Year's resolution was to start every new project, hobby project I did in C, and see what I wanted from a language. And it turned out I didn't need very much. But after about 4 or 5 months, I was getting frustrated with C because there were certain things where I'm like, look, I know from other languages this is really useful. And the first two things that I implemented were slices and defer, right? Wait, I'm going to get to it. This was at the time, right? And then eventually I was trying to fix other things. Like I was realizing, all the C things are broken, like the implicit conversions are bad. Like there's loads of things I actually kept trying to fix. And then realized at this point I should just make my own language, which is why Odin came about. Now, my views have changed on this over the years, actually.
I have another idea.
Yeah?
Sorry.
I'll explain. So my views have changed,
Okay.
but like I've actually don't even want defer in C because Eskil Steenberg convinced me of this about a year ago and I changed my mind on the topic and I went, actually, no, you're correct. So in C, when you actually look at C, you can actually just you can do this with most versions of C. Look at C, right? And then go line by line, statement by statement of shape effectively, and look at what the naive assembly should look like. And you can just map it one to one, right? You can just do that. There's no but defer doesn't do that anymore. It actually breaks that model. Defer, you can't just look at it because you're actually copy and pasting and deferring it to the ends of the scope. So now you can't do this trivial, like seeing the naive assembly code just from looking at it. Now I know that's not how it ever gets executed or lowered down or anything like that. So for people who are pedants in the comments, I know that's not the case. But that point there where Eskil kind of said that, I'm like, oh yeah, you're right, because that actually changes one of the essences of C. So I didn't want defer. Now, I'd still want slices. That's pretty much what I'd want. But from slices, you also get the variodic parameters as well, because in Odin, that is a slice. It's just got some sugar around it, and that's what it is. But that would be like the number one thing I would have, because I'd get bounds checking from it. I'd be able to find out the bugs that cause the bounds checking, because the bounds checking is not the bug, by the way. It's the symptom of another bug. So going out of bounds, I mean, for it. So having that would actually let me find the actual better bugs, if that makes any sense. So that's why if I have to have one.
So slices, but not defer.
Yes. If you only have one, yes.
Doesn't the defer argument fall apart? Like, doesn't that also disqualify for loops? Because, like, I mean, you know that I use the whole crazy defer loop construct. Like, the increment part of a for loop is the copy paste to the bottom of a scope.
You're right. It does get copy paste, but technically it doesn't have to be.
No.
You can still do the block tricks.
Look. No one knows what you're talking about now. You need to introduce the subject, Ryan. It's not like, my loops.
Sorry.
It's like, of course I know.
Your macro thing is, okay, ignore the macro trick that you're doing, right? Yeah, because that's the macro language. I'm just talking about C. Yeah.
Well, I'm talking about it as well, though, because that macro trick only works because of for loops. Because for loops are doing the copy paste thing, where you can stitch arbitrary comma operators in the increment portion, and they get copied and pasted basically to the bottom of the loop. So it's
but you can still technically write it as if you have. So you got let's say a code block here, another code block here. Like here's the init, the condition, the post, and then the body, and then they could just jump back to it. So you can write it like that. Compilers don't, but you can.
Right. I guess the fact that it's a scope also helps.
Yeah, and the scope helps and all this lot. But yeah, your trick does do the defer thing because it does. Yeah, I'm not explaining what Ryan's defer trick is. It's really dodgy is the best way of putting it.
I'll explain it. It's great. I think it's great if you're in C.
Yeah.
It's so the whole concept of the loop thing I'm talking about is basically not a loop. It's a loop with one iteration. But it's so for people who don't know, I'm assuming most people watching know, but a for loop in C has 3 portions to it. You've got an initialization portion, a check, a condition for whether the loop should proceed, and then an update portion, which is supposed to happen after every iteration. So basically you've got for int I equals 0, I is less than 100, I plus equals 1, I equals 0, that's the initialization condition, I is less than 100, that's checked every single time you're about to iterate, I plus equals 1 happens at the end of each iteration. The defer loop thing is just saying, there's this pattern that comes up a lot inside of all code, basically, where it's like you begin and then end, or you push and then pop, or you start and then stop. Like this constant pattern of like push, code that goes in between the push and pop, and then the pop, right? So all I did with the defer loop is basically, let's just wrap the for loop in a macro, where I've got a macro with 2 arguments. The first argument is what I want to happen at the beginning. The second argument is what I would like to happen at the end. Now, because of C, these have to be expressions. But because they're expressions, you can go ahead and put the the begin part inside of the initialization part of a for loop, and you can put the end part in the update portion of the for loop using the comma operator. So you basically say for int I equals 0, comma, or sorry, it'd be the begin expression, comma 0, so that your int gets 0. And then the update says, I will keep looping until I is not equal to 0. So basically the second I becomes non-zero, this loop terminates. And then for the update portion, you say I plus equals 1, comma, whatever the end part of the macro is. And so basically it does the loop once, but it does the begin part first and then the end part second, but you specified the begin and end together at the top is the only thing it actually gives you. So one example of this that I like, well, profiling scopes is a good example because you can say profile scope, here's the name, scope, and then it's got the begin profiling, end profiling, everything in between is profiled. I use it in UI a lot, so it's like, oh, I want all the text colors in this block to be red, so I'm going to say UI text color, and all that's doing is a push text color and pop text color, and then I fill out all the UI, and everything's got red. So it's dodgy, as Bill would put it, because it's a for loop, right? So if you use break or continue, you're screwed. Like, that's like, you just don't want to do that, really, in this case.
Yeah.
Because it's a loop. That's why I use the word defer loop instead of like defer block or whatever, or like, begin end block or whatever. Because I'm like, I want to remember that this is a for loop. But if you just kind of put that in the back of your head and just don't make that mistake, it's a pretty nice little meta language kind of thing. but yeah, no, it is a little dodgy though.
Yeah.
A little. How often did you write break or continue and didn't realize what's going on?
I basically never do it, actually. Like, it's not, a lot of people worry about it. In my experience, it's just not, I don't tend to write a lot of code that looks like that, so it's not actually a problem for me. But yeah.
Oh, there is a good comment. Could you define break and continue inside the macro and undef them at the end?
I mean, that kind of that ruins the whole point. Like, because you'd have to, every time you use a defer loop, you have to pound define break or pound define continue. But it's like, the whole point, the whole reason I'm using this macro at all is to be more succinct. It's because I don't want to have a push and a pop and maintain the two pairs of things surrounded, like,
and also
C's scope.
Thing doesn't work that way, so you can't define macros within macros as well.
Yeah,
right, that's effectively what you would have to do. It doesn't work that way, so like you can't do a define inside of a
define.
define.
My point is it would have to be at the usage site.
So it doesn't work.
Oh, Eskil is in the chat. Listen.
Oh, nice.
Okay.
So beware.
That's fine.
Eskil said, defer is an invisible go-to. A for loop ends with a curly brace, so you know execution goes somewhere else.
Yeah.
Yep.
This was the talk about what C features you lack. We kind of trailed off a little bit.
Yes.
But we've got the first disagreement between Ryan and Bill.
I have one.
We have a disagreement. Go on. Yes, right, go.
Let's go.
I've got one. Well, I think this is actually maybe in the newer standards. But the enum situation is just completely bad.
Oh.
Like, they should just have typed enums, like where you specify the actual base type. And I think this is in the newer standards, but I have not been living with
that's in C23, yeah.
Ah, yeah. See, okay, but I don't want to use C23, so that's...
Yeah, me neither. I still do the same trick where I will have the enum type be actually just a define. Literally, I go type def, we'll say U32 foo, and then my enum is actually enum foo kind, and then that's the, or foo enum, and then it just does that. So in C, when you're doing that, I mean, just to enforce the right size for the enum, because in C, at least the old specs, the size of it's kind of ill-defined. Like different compilers will say, yes, this is actually int size by default, and then other compilers, they'll go, it's actually the smallest possible integer representation. So it's actually inconsistent. So to make it consistent, you actually have to do this stupid little trick. Now, I know C23 has solved this problem, partially, because there's another problem with that, because people no, so he does solve it. No, it solved it. Yeah, but the problem I'm talking about is using enums as bit flags. So people think, oh yeah, but I get more of this extra type safety. I'm like, yeah, but bit flags, people use enums for that, and that's not actually, now you've got less type safety as a result. But let's not go down that train. That was a bit diversion. I'm sorry, this is all just like
So gentleman, you would remove different features. Okay? You lack different features, which was like first disagreement, at least in terms of priorities, okay? That's it. Now, the second part of this question, the inevitable part, okay? What features do you lack, and what features would you then now remove? Bill.
The question is, where do I start? No, really, where do I start?
And just to say, like, it's not a feature. Like, we don't need to be like thinking.
No. I would
features,
generalize.
right?
Like, for instance, a lot of the implicit conversion rules I would kind of remove. Like, they're awful. Most of them are. I'd just make it a lot of it explicit typing if I could. And this is what I'm just thinking of older days. Like, yeah, okay, that's the first. Like, that's one of them. I've probably got another dozen I can think of right now as well.
So you can trade then. If it's going to be long, we can trade.
Yeah.
Like, so implicit conversion rules from Bill. Ryan?
Implicit conversion rules for sure, like 100%. Actually, would it make sense for me to go back to lack? I thought of another thing, which is that you can't return array types.
Oh yeah.
You can't return array types. Like there's very silly things like this where you can't return. You can't take an array type and then return it from a function, and that seems stupid. Like that has to do with the type conversion rules because arrays decay into pointers and certain.
Oh, it's not just the type conversion rules. I bet it's also they forgot about it because if you actually try and define how a struct function looks like to return a typed array, it would look insane. Like the thing's going to be on the other side, isn't it? So I think it's one thing they forgot, and then when they have to add it, it doesn't look right. So the way you have to get around it in C is obviously you have to use a struct. Now in Odin, you can just return an array. It's great because it's not. I fixed that problem. But yeah, so the other things to remove. What else would you remove? Because the implicit type rules from me, from you. What would you remove?
Let's see. I would remove. I think I would remove the distinction between signed and unsigned integers. I don't think that makes any sense. I think it's a. I think that.
There will be blood.
The vast majority of integer operations are not signedness dependent. I think it's a feature of the operation, not a feature of the actual type. So it's like. So yes. I don't like attaching things to the type information in this way. And then have them implicitly trickle through to operations. I don't like that. I think I would rather just say, here's the data format, period. And here's the operation I would like to do. If it's an add, it's the same. Obviously, when you get into divides, when you get into modulus, shifting, like there are things where you would want it to be different based on signedness or unsignedness, but I just don't like... at the layer that C is operating at, I'm not convinced that it should have these fancy implicit like signedness rules applying secretly to these like polymorphic arithmetic operations. Like I'm just not sure I actually wanted that. I think I would rather have those things just as the op that I actually wanted to do when I actually do the operation.
I mean, when you write compiler backends, that's kind of doing like most like compiler backends just have a generic integer type, like LLVM. Let's just take LLVM because I'm used to using that. You'll have like say an I32 in LLVM, and then you say which operations you want to apply to it. So maybe a signed one or an unsigned one as well. Now, on C level, I probably disagree with you there, mainly because I actually do like the higher levelness of C in that regard, right? Because it's that one aspect where you do have this part built into the type system, rather than having the you have to now specify it like you were doing assembly. So I don't think that's a bad thing to have. I wouldn't remove that specifically, but there's probably a few things I would remove now. Now I should break out. Now we have modern C. Like another thing I would do here is I'd get rid of the stupid char, like sign the char, long, the short, all that lot.
Oh, yeah.
And just have the widths be specified specifically, with one exception being char, because then you've got one just for strings, right? So you have char on its own, fine, and also make that please defined to be signed or unsigned. Like probably just make it unsigned to be done, because that's not defined. That's a stupid thing. And then the rest you have like, I don't know, like uint 8 underscore t, uint 32, and have them all there, and just don't use any of the, and then you have one special one where you need the pointer types. Like just have those, the standard type def ones, you know what I mean? That's it.
Well, I don't know if this counts as removal of features or adding, because it would just be a change. But I think you should get rid of like all the stupid declaration syntax matches the usage. I think that's, as Bill said correctly, that's a horrible idea. That should just be out of the. But then it's like not C anymore.
That's a new language. That's not C anymore.
Yeah,
no, that's what I mean.
yeah.
Again, you can't fix it. That is something intrinsic to C. If you don't have that, you don't have C. Unfortunately.
Mm-hmm.
In what in what way, Bill? Like you mean
Because
like
it wouldn't be C anymore. It wouldn't look like C.
Okay. Okay, but like I thought it's gonna be like C was gonna break. Like if it was changed, like it's gonna.
Well,
like,
no, it just that's what I mean. It just wouldn't be C anymore. Is what I'm saying.
Okay.
That is kind of the quirk of C, right?
Okay.
It wouldn't be C without it, in my opinion. Even though I hate it.
To be fair, that's sort of what all these things would do. Like once you remove any of this, the language is not the same. Like it's not the same. None of the code will compile. Like all of it will break. So it's sort of always going to be a different language, which is why I was like, maybe I could sneak in. Can we just remove that from this?
But then we talked about pointer and how you declare and then use pointer. Are there other things like that, or is it only for pointers?
Oh no, all types, like even arrays,
Every
pointers, functions, everything.
Functions.
Okay.
Everything works that way. However it gets declared is how it gets used. So that may look weird, but as soon as you understand that view about how C works, you'll go, literally loads more starts making sense. And it's like, oh, that's how C works. And then once that dawns on you, go, well, that's stupid. But yeah, what else would I remove? There's a few more things I'd probably remove. I know someone I've seen in the chat, people saying VLAs, but I'm like, to me, they don't even exist. So yes, I'd remove them, but like I never use them in the first place.
I'd probably just take out const. I just don't think it's. I don't like the idea of something being read only. In my head, is not a type system thing. I think that should be. I don't know. I use
caveat people,
for sorry. What was that?
For C, because I know there's going to be pedants in the comments here, but don't you know immutability in these functional languages is really good.
Yeah.
I'm already predicting the comments. This is my problem.
Right.
I agree with you. It's with const in C. This is the thing about Odin, because I actually encoded directly into Odin by conventions. So I would kind of remove const as well from C, but then I'd have to replace it with the other things that it uses it for. Like for instance, one of the things is static const. Right, so static const means this is now in a read-only data section effectively in most compilers. That's the first one. Another form of const is like when you do char const for strings. That one now means you've got a read-only data structure for your literal, effectively. And that thing, there's a nice convention to say, hey, this is now a string value you're passing around. You now read it as a string rather than having it as like a string buffer. And then the third use of const is to denote input only parameters effectively to functions. Like you've got a pointer, and if it's got const on it, you go, oh, this is for inputs. If it's no const, you know it's going to be in out, like it could mutate. So they're pretty much my only 3 use cases of const that AI ever used. And now I know other people say, yeah, but I use const, it really helps me. And I'm like, great. But actually, I found it never did help me, and it's just me typing more.
Yeah. I agree with that.
C is just mutable everywhere. That's the problem. It's like it's the wrong language to try and add immutability to.
Yeah.
So if we could remove const, that'd be great, but I'd have to replace it in. You'd have to add those new 3 features. So you've actually added more. You've taken away one to add 3.
Yeah, but that's because like keywords in C also often mean different things depending on where they're placed. So it's like
like static. Static means like 4 things, 2 or 3 or 4 things. Yeah, it's awful.
Yeah, I mean, it's hard to say. It depends on what you call C, because there's ways to declare read-only stuff today. Like, so you can already do that. If you call that C, then it already has that feature. If you don't, then it doesn't. But, yeah.
Yeah, like there's extensions to say which data section it goes in, right?
Yep.
So you can already do that. And in Odin, we just have literally an attribute that goes O data to put it in the read-only data section. Or you could always specify a specific section if you want a specific one as well. So if you class that as C, like probably me and Ryan do, then yep, it's already there and we don't need const. But like there's also like, that's another thing. I'd probably not remove static. It's like you'd go make static clearer, because static, God, what's the different versions of static? You've got static, like static const, so that's read-only data section. Static on its own outside, which on like a function, which means it's this internal linkage. Static on a variable within a procedure now means it's an invisible global. What's another one? Oh yeah, the static. This is a C99 feature, if I remember correctly. You can put static on like a array length in a procedure argument.
Mm-hmm.
I can't remember the meaning of that, but that's another version of static you can use. There's probably some more I'm forgetting about static. But like, look how overloaded this concept is. This one keyword, and it does like four or five different things.
Yeah.
I would love to write a compiler for C and maintain everything in this.
Can we include the standard library in this too? Because I would remove basically the entire standard library. Like it's just all bad,
Same.
pretty much.
Yeah, that was going to be my next
good.
thing. I was about to say remove everything pretty much except for memcopy, memset, and memmove.
Yep. Yeah. Yeah, it's all bad. Like you just want a better code base layer, period.
And actually memset's still pretty bad. Like I technically just want mem0.
Yeah. Yeah.
What do you mean it's bad? It's bad.
Well, memset is a weird... If you actually look at the definition of memset, it's got a pointer, the value you want to set, and then the length. Now, the value you want to set is an int, right? Not a byte, an int, because this is so old when there was only integers in the language. That's all they could do, right? That's why it's an int. But then the thing is, I would argue, if you look through any person's code base, I would say 99.999, that's 5 nines, % of the entire code base is just going to be memset to 0, and then that 0.001% is going to be set them all to 1. I doubt there's any other case really, unless it's for some like debug reason, they're going to set it any other byte value, which means it's kind of a useless function just to have that parameter when it's not just pretty much 0. Memset, memmove, and memcopy, really useful things, obviously. But other than that, most of the standard library of C is so bad, you pretty much have to replace it all.
Yep.
Bad in what way? Like you need to be like a bit more. I know everybody
would
loves...
you like to take this, Ryan, or shall I?
Everybody loves to say like standard library, C++, dog shit and stuff.
I mean, pick an API and we can dig into how bad it is. Pretty much, like there's a huge list of things we could talk about, like things implicitly mallocking, things that are not they don't even like certain APIs. Obviously, everyone knows about these, but it's like, well, not everyone. That's the problem. There are certain APIs that don't even allow bounds checking. They just go until they hit a null terminator. Maybe, and then it's like everything is built around. Yeah, it's like everything's built around these like null terminated buffers. You just pass a pointer. Things implicitly malloc. It's a complete. There's no actually good story about how memory is allocated. There's no good story about how you're going to pass down like variably like slices basically into one buffer. Basically, like it's always assumed that you have one buffer, one slice. And it's null terminated, or because it's null terminated, basically. It's one buffer to one slice, whereas like the actual pattern that you want in programming is like, no, I have tons of slices into one buffer. And that's why you need a length delimited concept. Like that's why it can't be in the buffer itself.
Yeah.
So all of those APIs are really bad. I don't know. We can dig into any of them.
Like I was
really,
thinking malloc. Malloc's pretty bad as well. Like people may not understand this. So there's malloc and calloc, obviously. So malloc will return like literally malloc. All it does is it takes it's called calloc, right? That's how you pronounce it.
I would say so, but it's just funny how you say obviously. I'm like, yeah, it's not obvious.
No, it's not.
But...
I know that's a joke. It's calloc, right? But the thing is, okay, so you got malloc. For people who don't know malloc, it's literally you say it specifies a size in bytes, and then it returns the allocated amount in gives you a pointer. People say, what's wrong with that? Well, first off, malloc has no guarantees about if it's zeroed out or not. Right? Which you may think, oh, what's wrong with that? And the answer is, well, I would like it to be consistent usually, but then people say, no, there's the calloc call, which that allows it to be zeroed, right? That's the zeroed form. And that's like, oh, that's great. Now, here's the first problem with all of this. First off, we haven't even been able to specify the alignment of this heap allocation that you're doing. It's also a global heap. It means you can't have multiple different heaps everywhere. Or specify how they're going to be sorted. The other problem you've got is you also got this realloc or realc. I don't know how you pronounce it, but that one, the realloc. That one is also when you pass in the malloc or the calloc one, it still works. But the problem is if you did it with calloc, the realloc will not zero the new stuff either for you. So now you've got this stupid nonsense going on. And also that also doesn't specify the alignment aspects. Yes, I know certain versions of C allow for the alignment, but even they don't have them all correct. Free again is just takes in a pointer. And sometimes you can say, well, we know the length. Can we not just also specify the length? And it's all these just levels of, it's actually a really bad API. Because it's also assuming like heap allocation based things. And that's why people think manual memory management is so hard in C. It isn't. Just malloc is hard. Malloc is awful. You don't have to do malloc.
Yeah.
What C stands for in calloc?
I have no idea, actually.
I can't remember. No,
Clear.
I can't remember.
It stands for clear.
It might be
I bet
clear.
it
It might be
stands for
cleared.
clear.
And also the other thing about calloc, the clear alloc, that people don't always remember is it takes in 2 parameters as well, not just one where it said byte, it takes in 2. Because the whole idea of calloc is you're meant to be allocating an array with it. Now, I think I remember correctly which order it goes in. The first parameter is meant to be the element size, and then the second parameter is meant to be the array length that you're allocating, right? Hopefully I've got them in the right way around. Because what's happening here is the idea behind the API is that it will then do it'll do the multiplication check inside to make sure you have not overflowed. Is one reason behind it. Because back in the day when you had really small allocations and those numbers were there, they could overflow, and makes sense. But the other problem is it's also like, well, you've now got 2 parameters. Yes, it's whatever the API is, but now you've got this stupid pointer thing. You have to worry about everything else, and the order has to matter as well. And then also, you still can't specify alignment, which people say that doesn't matter. I'm like, actually it does quite a lot. And then it annoys me so much. It's just bad. It's so bad.
We've got a comment that C in the calloc stands for contiguous.
Oh, contiguous. Okay, because malloc wasn't contiguous before somehow.
What?
I think somebody...
Yeah, because it's like an array, right? You're allocating this element size and this many of them contiguously, right?
But malloc returns contiguous allocation. I don't understand what people
but no, don't.
about.
It's doing different. It's just
Honestly, if it was for zeroing, it would be zalloc. It would be quite nice in terms of pronunciation.
Zalloc, more than
Yeah.
calloc. Yeah.
I mean, I'm in favor of like, you shouldn't compress a name until you've proved that you use it everywhere. And so like that's another like side.
But they
small
had to
aesthetic
compress
detail.
names. That's why all of the C standard library is 8 characters or less.
Yeah, they had to, and I don't really fault, like, there's a lot of mistakes in C's history. I don't fault the people who made that. I make mistakes all the time. It's not that I'm like, oh, they were so stupid or whatever, but it's like today, when people carry forward this style of like, let's just compress the crap out of every single name, no matter how often we use it. It's like, my mental model is like, when you build an API, you want to start with the most descriptive thing, and then if you find yourself calling that everywhere, then you want to find a more compressed representation for it. So like, the API name to start with when you're designing this should be like heap allocate and 0 or something. And then if it turns out that you're calling that everywhere, which I question whether you should be, then it's like, then okay, then you go down to zalloc or whatever. But before that's like a side small aesthetic thing. So
yeah.
Okay. We were on the train of features that you would remove from C. By the way, that's
there's still some more I'd remove. Again, with the standard library, someone was saying, what about math? And I went, actually, quite a lot of math I'd remove as well.
Yeah.
What do you mean? Math is math. Math is not C. You cannot remove math.
Not with that attitude. No, there's some math.h header is what I'm referring to here. So yeah, there is some good stuff in there, like, again, but it's more of a, for people, technically speaking, it's not part of libc, it's not part of libm, isn't it? Like, it's its own thing. But it's part of the C standard, but it's most compilers have its own like library. It's confusing.
Are we done? After these removals, C is perfect?
To be clear, no. It's not, because again, you'd have to change the language so much. Like, I already tried to change the syntax, and Bill was like, you can't change the declaration syntax. I'm like, okay, well, so it can't be perfect. But one thing is like that I would probably just spell out immediately is like, Bill and I probably both agree that you would completely cut out like almost everything from C23, except maybe typed enums. Like there's a couple of things sprinkled in there, but we would probably both remove a lot of the newer stuff. So we're thinking from the mental model of like, what would I remove from C99 or C11 or something?
Yeah.
I would probably remove atomic types, by the way, from C11. Like I would not. I think that's another thing. Like that should be in the operation. Like that's not a type thing.
Okay, so this is one thing I've been actually going back and forth even for Odin, actually. So this is related now.
Okay.
So at the moment, Odin has no atomic types and you have atomic operations.
Mm-hmm.
However, I have been considering adding atomic types just because then it prevents you from adding, like, let's say you got A plus B accidentally and you're not doing it through the atomic operation.
Mm-hmm.
So it prevents those mistakes. But I don't usually have those mistakes most of the time anyway. So it's kind of like, it doesn't benefit me, but I'm just also thinking about other people, right? So I'm trying to think, does this actually help or not? But I also wouldn't want, by the way, I wouldn't want default like sequential consistent semantics on atomics either way. Like if it was an atomic, it would be opaque and you have to use the functions to do what you need to do.
Yeah.
Like you couldn't do A plus B and it magically does it atomically. You have to call atomic add.
Right.
And do it that way.
Mm-hmm.
I'm just trying to think, what else did I remove? Most of the core library, that's for check. Yeah, static, replace const, yeah.
Yep.
Okay, so this is not, I don't need to remove it, but I can. There's no need for it, right? But I don't just have 4. I wouldn't need while or do while.
Yeah, that's definitely fair.
I can. You can live without those two.
Yeah, just one loop construct, simplify the control flow structures down.
But I don't have to remove it. It's just you can do it.
How many are there in Odin?
There's only 4.
4. Okay.
There's only one. There's only one, the for loop.
Yeah, you would make C into Odin. That's what you would do.
No, I wouldn't actually.
Shouldn't you call it loop? Like for is such a strange keyword for all loop constructs.
No, because we also have like the for in, so for x in y.
Okay.
To keep, because that's what people expect, right? I know it's a really weird name, but people expect this.
Yeah.
So you do what your expectations when you come to language design. You don't just try and go, well, I'm going to describe this tabula rasa, and yes, it should be called loop. It's like, no.
There are languages. There are languages that the loop is called loop. I can't.
Yeah, Rust has one called loop, and that's effectively a forever loop.
Okay, I think there's some more maybe. But I've seen that.
What else can I remove from C? I'm trying to figure out all the complex types. That's another. There's loads of stupid things you can remove.
There's a replacement I would do, which I would remove the arrow operator, like just make it a dot. Like every struct implies an address to some degree. I mean, I guess technically it could be like funged from some registers or something.
No, so technically you're adding a feature there. So you're removing the arrow operator. By adding to add the dot to make it do an implicit.
It's a net zero. It's a net zero.
Yeah, it's net zero. We're fine. Net zero features. We love this.
Net zero. Okay. By the way, we've had some disagreements here. Okay. I just want to point out this fact. I cannot recall them. I just want to point out there was some blood. There was some shock on the face.
Wow.
Ryan said some outraging stuff. Okay. It's all on video. We can review this later on.
Yes, of course. We disagree so much.
We should, I think, move on from this question. Because I feel like we could spend entire episode in this one.
Yep.
Now, I think we need to pick up the pace. You cannot just like stylistic features, like, remove this. Like, no. So, serious answers, okay? What do you think about the C weird initialization style? Like, you create something and it's not initialized to 0. It can have garbage. Like, is it?
Yeah.
I would flip that. Odin does the right thing.
Do it by 0 by default. I understand why back in the day it wasn't the case.
Why was it?
Yeah.
It made perfect sense because it's actually expensive to 0 things back in the day. It really is. But nowadays it's kind of really cheap. And also compilers can optimize it out really easily because it knows it's going to be initialized at certain points and do it that way. So you'd have some way of, like in Odin, you do the -- to say this is explicitly undefined, or uninitialized, you say. It isn't undefined. It's just uninitialized. And then opt into that because that also gets a whole category of bugs are removed from C as well. Like all of the invalid pointer stuff goes away and you only get the nil pointer pretty much. And people say, nil pointer is bad. And it's like, no, actually it's fine. It's really easy to catch in a debugger. But if it's added some random one, it could be valid memory. And there's the problem. It's like you don't really know until you go, oh, okay. So having something consistent like that would help.
Yeah.
Ryan, you agree on this one?
I agree. Yeah. The way I write C is like in my head, I prohibit declarations without equals 0 or equals braces 0. Like in my head, I just like, if I see code doing that, I'm like, that's not allowed. Like, don't do that. So I have to write it that way anyways. It'd be nice if it was just like, no, we just 0 by default, obviously. That's the correct design for today.
All right. Great. Quick, smooth, nice. And you all agree as usual. And error handling in C. Okay. Like the setting the number error node to the exit code like this, slide like that.
We've already said we get rid of the standard library, so that's
that's an
solved.
API.
That's an API problem.
Okay. So you both just like how would the error handling look if you were to design?
Like any other bit of code?
Yeah.
Just return. You return like an enum.
Return values.
You just return. You just values. Errors as values. Done, and they're explicit.
Yep. Yeah.
That's
Yeah.
how
I
we
would
do
say
it.
I would.
Yeah.
This might be a point of disagreement. I would opt for thread locals probably more than like a lot of people want directly explicit things. Well, okay, couple things here. I would say errors as values. It's important to me that it's not errors or values. Basically, error values or the actual value you wanted. I want both all the time. So I want both to come through no matter what. Like the return should be a struct, not a union. That's the value that you expected to get from the function, and any possible messages or errors that like information about what happened in the function, basically. And the second thing I would say is that something I might do that Bill might not is I might put the messages part into a thread local more often. Like that's implicit thread local more than he might. So.
Yeah, you probably would do it more. I'm not necessarily doing it that approach, but that's just an API design thing. It's not necessarily per se language. Yeah, but I agree with that. So that's one thing I know there's going to be a lot of people, not a lot of people, but some people will disagree with, like the union versus the struct thing, or another way of putting it is the product versus the sum type thing.
Right.
And I like, this is the thing about multiple return values in Odin. Like I actually like that I have the value and the error be separate because, how do I put this? The more mathematical minded people who like the Haskells of the world, they like doing the union approach, the sum type, because it's like, well, it could be either valid or it's invalid. So you need to specify the two states correctly in the type system. And then it's like, yes, but in practice, you actually have like a third state as well, which is a partial success as well, right? You've got this value, which is partial. And then you also want to kind of signal how it kind of partially failed. In a lot of cases, this is what you need to do. You can't just always revert back into the actual like the function, do it all that way and you need to do this. So you have those three states that you want to deal with. You've got success, no error code, partial success, error code, complete failure, error code. And it also actually helps when you're actually mocking out code as well, because you can actually ignore both, one or the other, or both as well at the same time. So you can figure out how you want to deal with it. And you can just pretend as if it's working successfully, and you can just design your data structures that way. But yeah, that's just something to argue with. And I know people disagree. Well, you could always just have a third state where you have like this, not like a union of all three options. Don't you know this? And it'd be easier. I'm like, we're using C. Not everything has to be solved in the type system. We don't really have much of a type system in C, man. So
for some reason, when you Bill are starting to mock, like the mock language, like it's incredibly funny. Like I'm all ears. Like if you're doing that, it's like, oh.
No, it's problem is I've spent enough reading comments on the internet to go like, I can always predict what they're going to say, and then they're going to tell me I'm wrong, and it's like, fine, whatever, sure, go ahead, great, fine. I've read it all before, and it's not like I've not heard these arguments before.
Okay. Yeah. Some alignment on this part, and some like okay, 90% alignment. Yeah.
90. Yeah.
Okay. C, lack of build system. Yay or nay?
It does have lack of one. That is correct.
What? What?
Yes, it does lack a build system. That is correct.
But is it? What's your take on this? Is it good or bad thing?
I think if you solve the textual inclusion problem, you'd probably fix this. Like I don't know if you really want complicated build stuff in the language. Like I don't think it should be there. I don't know what people are doing that makes their build so complicated exactly. I mean, I know obviously if I'm picturing like, Fortnite or whatever, it's like, okay, like people go nuts in huge corporations, but or just massive organizations doing really complicated projects. I understand why it gets more complex there. But in like the vast majority of code bases you actually look at, people are like massively over engineering this problem. Like pretty much just full stop. And so I'm like, I don't know how much you actually need there. I don't know.
I would split this up to 3 different aspects of the build system here. So the first one was the textual inclusion thing. And because C is in order with its declarations, that's why you kind of need header files, because you need to pre-declare things before you can use them.
Yeah.
So that's why header files kind of come about. And also, if you want to reuse things, you have using like multiple translation units in your build system, because C doesn't really define anything in that regard, then yeah, that's why you need the header files. They're kind of consequence of that aspect. But I'm trying to think of another way of phrasing this one. So that's one aspect, is all the header file stuff, but it's also people like organizing things like taxonomies, and they don't really need to. People are afraid of like, well, my file is more than 100 lines long. I need to make another file now. And then they're not thinking about the cost of like how slow it is to open and read a file. And then also textually include that everywhere and then add it to the linker. Like that's a really thing. If you look in the Odin code base, we regularly have 10,000 lines in single file. And is that hard to deal with? The answer is no.
Yeah.
And you go, of course it's hard. I'm really struggling even with 100. And it's like, I don't mind the code bases I'm even in, because I always just kind of like searching around the code, jumping to the next like functions everywhere, and it's fine to read. I can just read from top down and it's okay. Putting it across files does not make it easier to organize or read. It doesn't. In fact, it probably makes it harder now because it's spread across multiple different things, and my text editor's not that clever sometimes.
Yeah.
So you think it might be better for your taxonomization problem. That's the second aspect. The third aspect I wanted to talk about was actually like the adding of linking. So some extensions to C have something called pragma comment lib, where you can specify in the source code itself what you're linking against.
Mm-hmm.
Now, I took this idea in Odin and literally went, actually, I want to codify this correctly, so it's not just like thing, and not just that, it also associates what it's linking against with like the procedures and the variables that you're linked against. So if you don't use any of them, they don't get linked against. Well, that lot. So that's the other case of the build system is, like when I was designing Odin, I was trying to get rid of the need for an external build system entirely. So you can just go Odin build dot, and it does all of your code done, right? Because you've specified the linking parameters in the source code itself.
Yeah.
And if you're keeping it external, that's when you get these complicated build systems, because it's all going to be different. But keeping it in the code is easier to maintain, easy to do, because it's got a standard. The problem is that this is going to be a problem with advertising Odin. So always people ask, oh, what's Odin's build system? I said, we don't need one. That's really bad advertising, because it says, what's the build system? We need a good build system. I'm like, no, we don't need one. And it literally goes over people's heads. Like, what do you mean you don't need one? So it's, you're not doing anything complicated. I went, no. It's in the language. No. It's like, oh, for goodness sake. So you can't always, this is another thing is about marketing is like, we don't need one because we've just done the thing.
Yeah.
You should say you have one.
No, but it's like, we do have one, but they said, okay, where is it? And I'm like, no, they get confused.
Okay.
So I'm like, but that's what you do in C, because you can do that in some extensions of C. You can just do the pragma lib, but it's not as fancy as Odin's approach, by the way. It just links always, regardless of if you never needed it or not. But yeah, you got those 3 aspects to deal with, and you could improve it in C, obviously, if you were making this new C extension, because it's technically adding a feature. Mm-hmm. But I don't think it would work. There's so many different. It's CC, because you'd need to fix loads of things. You have to get rid of you have to have some form of out of order declarations to get rid of the header files. You would need to get rid of the textual inclusion, and also you'd have to specify in the linking stuff in the language, so you don't have linker as technically a separate stage explicitly anymore. Mm-hmm. But then you got a new language, and that's why I made Odin.
Yep.
Okay. Now. On this question, there was agreement.
Yes.
Yeah.
Unfortunately.
Unfortunately for you, yes. There's no. Come on, Jerry. You're not even getting this reference, Wookash.
Okay. We talked about build system or lack thereof, features to remove or to add. I want to ask about your opinion on C macros. Ryan, we already learned that you like macros to some extent, at least for the for loop tricks.
Yeah.
Now,
well,
what's your
also I do
opinion?
it for, so one thing that Bill brought up of like that he does from C++ is default values. I also use macros for that, just to be, so that's another one of those fancier macro tricks. Like I've got a function, I define the function I want, it takes a pointer to a struct. I'll wrap that in a macro. The macro takes variadic arguments that I use to initialize the struct itself. So then you can call a function and say, there's a bunch of default parameters, and then you can also say like, oh, like .foo equals 5, .bar equals 6 in the function parameters themselves. So you can do that with macros. My opinion on macros is that I think that they're probably one of the only reasons why C has survived, like to the degree that it has, because people can shape it into whatever they really want it to be in a lot of ways. Because the base language itself is just kind of not as expressive as you'd want for a number of problems, and so having a very simple like replacement system, simple, you might you might pick bones with, but it's but having some kind of replacement system is good. I'm not sure that if you designed it from first principles, you'd make it a textual replacement system. That seems like probably not the correct. If you wanted really good macros, I'm not sure you'd go to textual replacement.
You do hygienic macros like every other language does.
Yeah.
If you want macros, that's what you do. But
yeah,
Can you say hygienic macros? Can we interject?
hygienic macros.
Yes. Can we explain that?
So explain textual macros, which is how C works. They literally just replace the text that like in the code. Hygienic replaces the AST. So it's kind of a lot much safer in that regard. And it doesn't really change the text. Now, the thing is, C macros, and yeah, I know it's not my turn now, but I'm taking the turn. Screw it. This question.
No, we need to come back to Ryan.
No, we'll come back. But it's still the same. It's still the same thing. But like they need to exist. Like the macros are there to extend the language when you find something lacking in the language. And it's obvious thing for macros are clearly for even include is a macro. The conditional compilation is one, and then also adding language constructs which are missing, which is kind of like what Ryan's doing with a lot of his stuff. And that is what they are. To me, macros are the need for a macro is usually a sign of a missing language feature or a language construct, usually. Not always. I can think of, again, the exceptions where it's not the case. Like I'd say conditional compilation isn't necessarily it's fine in the macro system, at least in C. But the rest, I think it means there's something lacking in the language, which is why Odin doesn't have like macros when I designed it. Because I kept thinking I was going to need some sort of like, not in say macros, but something like that to achieve the goals. And every time I came across it, I went, no, there's a better way of solving this. Oh, there's a better way of solving this. Just add that feature directly, which I was mimicking with a macro. But yeah, so they're needed for C. Again, C without its preprocessor wouldn't be C, because we're not talking about, no one ever thinks of C without the preprocessor.
Yeah.
Try write C without a preprocessor and you won't get far.
Yeah. I think there's also, on that point, there's a distinction here between whether or not you're building like core ecosystem building blocks versus whether or not you're building a kind of the best. You're putting in lots of engineering resources to build the best programming environment for you personally. So in the case of Odin, it makes perfect sense that he would add these features to Odin itself, because they provide the needs he was missing from the base language itself. In the case of C, when it's like supposed to be this like lingua franca, like, oh, this is a ton of code is written in this, it's spreading far across the ecosystem. Ideally, the kernel of it is actually relatively small and constrained. I mean, it's not, but it's more so than something like C++, right? So it's better in that regard. And I think if you're doing that, you need some kind of macro system so that you don't end up having an ever-growing spec for arbitrary future uses of the language, right? If you're building like, okay, I'm going to sit down and build the best thing for me to program, then you don't need macros, because you can just go and change the actual code. Like you can go change the tools that you're actually building. If you're trying to build something that's going to last for like decades and decades, you don't really want to be in a situation where you have to keep revisiting the spec, and you have like all these different compiler implementations. You have all these there's all these like competing interests over the language itself because it's like this widely distributed thing. I don't think for that situation it makes less sense to try to solve missing language problems via changing the language spec, because it's just, it works much less good when it's not this like centralized, I'm the designer of this tool, I'm going to do exactly what I need to solve this problem. And so I think long way of saying I agree with Bill, I guess, that it's like, no, C needs them.
C needs them, but I'm going to make a caveat on here as well. C needs them. They're necessary for what it's doing. However, my point here was about this Odin thing was I think it's a lack of a feature. If you have a language which has a lot of macros ability to, like the good example of this is Common Lisp.
Yep.
And there's something called the curse of Common Lisp, which is where, because of how simple of a language is, and you have these basic ability to do all the macros, each person who makes their own macro set is now incompatible with anybody else's piece of code because there's no idioms, common shared idioms anywhere within your stuff. So if you, like Odin, we have a lot of things built into language because we're effectively encoding conventions and these idioms in the language that everybody else can then use. Now, weirdly, C does have some problems when it does all of its macro stuff, right? People have like incompatible conventions, even just incompatible like namespace collisions and such, because again, it's not hygienic. It's one giant namespace. Mm-hmm. But for some bizarre reason, C hasn't actually suffered from the curse of Common Lisp as much as you'd expect it should do. Mm-hmm. And that is actually surprising to me. But it might not be... I think it probably is just because of what the nature of C is, rather than say the nature of Lisp, or Common Lisp. So it's weird. Like there's some just historical things, and it'd be nice to actually just research more of the history of this, like the psychological reasons why people do certain things in different languages. But this is one of those where I've not researched much on, and I'm like, why has this not happened as much as it did? Or maybe it did. It's just that people who use C hit it quicker, like the curse, and they went, oh, we just need to stop doing this.
Yeah, my intuition, I'd probably go further in the direction of hitting the curse than most C programmers, just because I've got like metaprogram files that are not C at all, and so that gets further in that direction. I think that my intuition would suggest that it has to do with the fact that there is there's a significant portion of the base language that is concrete. Like it's. You see this everywhere in programming discussions. People really want to go to extreme directions. Like they're like, logically, like if you have a macro system, it should lead. If you take that to the limit, it should lead you to the curse of Lisp. But it's like, we're humans. We're not operating at the limit. We're operating within the bounds of psychology. So the fact that there is a concrete language and then there's some ways to spiral off of it, I think keeps C much more grounded than something like Common Lisp.
Yeah.
So that's my intuition. Obviously, I haven't researched it or anything, but that's how it seems.
No, it's one of those because it's not. I could just go. I do try and research a lot about psychology of different people's languages because that's how I approach language design in general. It's a psychological perspective, not really a type theory perspective. Even though I know the type theory stuff, it doesn't need to help me that much. But it is interesting. Like, why did C not spiral off as badly? But the problem is, it probably did. But we haven't seen it as much.
Yeah.
Well, can you elaborate on the psychology of the languages a little bit more? Because I have no clue.
What I mean by that, is how people think about a language and how they use that because of how their mental models compared to the actual like rules of the language. Like again, as I explained to you earlier about was like C's declaration syntax. Most people, when they learn C, don't actually understand how that works. They've got a basic mental model of how it works, which is wrong. Like it's always wrong until they actually learn it. And then they go, wow, I understand it now. This is retarded. But it is that is kind of the thing, is they have this mental model about how they approach things. So this is how I've always approached Odin, is very much how do I think people are actually going to interact with it, and also how do I see them interact with it, and then I ask them effectively through certain questions, never directly, because if you ask them directly, they don't answer correctly. You have to ask them certain other questions to get the answer that you want. To find out what was your mental model, what were you actually expecting, what were your intuitions here, because then you'll find out that these intuitions that people have are really complicated. They're not simple. Like they've got a load of assumptions. They're not an instincts going in there. And you go, oh, that's why you're assuming this should work, but it doesn't work this way. Like there's loads of things in Odin which are very ergonomic to make it those intuitions, but there's loads of places where it gets against their intuitions. And usually in those cases, I've done it by design. Like, no, it's on purpose that there's some friction here. But it's like the same thing with C. It's like, why are people using the way they use macros? Is it just conventions that kind of people have got stuck to, or is it just naturally that's how people think? And that, I think that's a much better way of like approaching language design rather than thinking about the proper type theory, because people don't use type systems the way you would hope they do. They really don't. And usually they need to circumvent them as well. So when they do circumvent them and they've spoilt all your amazingness of like, but this was meant to be perfect. And it's like, welcome to humans.
All right. This was what the C macros. Yes.
Okay. C macros. Yeah. That's
now we're moving on to the next large topic. And I think, Bill is first now.
Yeah.
Okay. Are you ready?
Okay, go ahead.
Undefined behavior.
Oh, I'm first. I'm sorry. This is my rant topic normally. You've probably seen me on the internet ranting about this before.
Yeah. But also paint a picture for everybody who is listening. What is it like? What's the deal?
Okay. So the first, I'm going to phrase it as UB specifically, because that's how most people call it. And that UB is in itself undefined what it means. It's a bit of a joke. So when you read the C specification, right, there are things in the specification that they specify. There's also things that they specify, they state that cannot be specified, right? So this is undefined behavior. There's also things in the C specification which they call undefined behavior, but it's not that they haven't defined it. It's more that they can't observe it. So I would class this as unobservable behavior, right? So a good example of unobservable behavior, for people who don't know, is anytime you violate the memory model in C, the compiler assumes you're adhering to it, so therefore it cannot observe your violations. So therefore, however it optimizes or deals around it is now unobserved and thus undefined. That's one aspect. Now, the problem is a lot of the things in C which are undefined are trivially definable, like extremely so. And they should just define most of it. Now, the argument, the problem people are going to batter at me is that there's two sets of things. Well, the C specification can't define everything. And I'm like, you're correct, because there's different platforms. But you should have these, why we've always said, you have these mini specs where they're platform specific. So now you've got platform defined behavior. And now people say that's still UB. And I'm like, no, it's defined for that platform, right? Yes, that is maybe undefined across all the different platforms. No, it just means you just have to define where you're defining it. Is it defined in the spec, the compiler, the platform, or the library code? Define where it is. Right, there's a bunch of things you could just define how that behavior is. That's the first thing. Again, there's some things that cannot be defined. Like, again, if you're violating the memory model in C, you can't actually define how that should happen. So in some cases, you just make some people redefine that. Some languages say this is illegal behavior, so they change the name of it. But in C, we say UB all the time. There's the other aspect where people say, don't you know, and this is actually one that really frustrates me enough. You can probably guess where I'm going, Ryan. When people go, we need undefined behavior to do optimizations.
What?
This is an oxymoron. Yeah, so they will make this argument, and it's a really common argument, and I know what they mean by it, but they don't. And they'll say, it's like, no, we need undefined behavior in order to optimize code. So the problem is again, they've merged these different concepts together, put them all in together. And I'm like, okay, great. If you're just talking about the memory model, the basic memory model, then yes, you need to make assumptions about people's code, right? You're defining how things work, right? So you can then optimize on it based on those assumptions. Now, if people violate that thing, yes, it is undefined, but that's not you relying on undefined behavior. You're actually relying on defined behavior to do optimizations. That's the first aspect. The other aspect of undefined behavior, which is what really pisses me off, sorry, my language, is where people say, yeah, but we like to be able to make arbitrary definitions. So we can say this is undefined, so therefore we can do whatever we want here to then optimize. If you've got arbitrary rules, that's not optimization. That's garbage in equals garbage out. That's not optimization anymore. Optimizations require rules to follow in those guidelines.
Yep.
That's it. So this is why I've had this UB rant before numerous times. It's just, I get annoyed talking about it to people because they just, I know I make distinctions, but they don't, and that's fine. That's not necessarily an issue, but it's just very much like, stop using this word, undefined behavior, because it's literally undefined in itself.
All right. Thank you for the rant.
There we go. Sorry, there you are. You're welcome.
That's good. Yep.
Now, Ryan, you obviously disagree with Bill here. So can you just say it out loud?
obviously he does, yeah.
Obviously. No, I mean, I couldn't have said it any better. I think, like, one of the things that Bill was touching on is, like, it kind of, I can call back to the concept that he brought up, which is de jure versus de facto. Everyone de facto is doing, it has to look to the platform, has to look for these things. Like, they can't rely on just the C spec. And so all Bill is really saying is, like, let's make the de jure, like, what we actually write down, let's make that actually map to reality. Like, let's not have this, like, completely arbitrary external space where people are zeroing in on this, like, abstract language world that has nothing to do with what people are actually doing. Just actually write down what the rules are that you're following, that people actually follow, so that it's much easier to find this information. Like, because everyone has to write this way anyways. Nobody is writing just to the C spec. So, I don't know. I guess I'm sorry, Wookash, but I agree wholeheartedly with him. It's like, this is just not great situation. Really.
No, and I it's the other aspect where I'll get another pedantic thing I want to moan about again. Sorry, the rant. But the point is that a lot of people say, but we can't have these optimizations if you define this rule. I'm like, no, what you mean is you can't do these passes. Right? They're not optimizations. Again, I know it sounds like I'm being a pedant with the words here, but I'm like, no, you were actually saying things just wrong.
Yeah.
Like, there are certain compiler passes you can do on your code, and they may be optimizations, they may be not.
Yeah.
Right? And said, but we can't do this anymore. I'm like, and?
Yeah. Yeah.
Okay.
Yeah, I think it's a symptom of a problem, which is that people are working on problems and they're really narrowed in on that. Like, they're like, we need to make these benchmarks better, and we can cause these passes to occur, which will make the benchmark numbers look better. But they have to, like, zoom out and think about what's the actual analysis of the situation. Like, who's using the compiler? What does their code look like? What do they assume their code to what do they assume their code to actually be turned into? What do they assume that the compiler will generate? And are you violating that? And if the answer is yes, then that's a bad decision. You should not have done that. So, the spec should address this and just define what it is people are actually meant to expect.
There's also another aspect, I'd say, which is tooling. The compilers, if you want to say you've got illegal behavior, let's call it illegal behavior, just to make it more clearer, right? Well, why doesn't the compiler just tell you you're doing? Because a lot of those cases, it knows.
Yeah.
So, and I know it can't always figure out until it's got to the back end. You can't do it in the front end, you can do it in the back end. But, like, I would rather have this tooling to say, hey, you've made an error here. This is violating the rules. Stop in the name of the law, kind of thing from Oblivion. But, like, and then just literally tell me, fix this, please. Just like fix.
Yeah.
All right. Undefined behavior topic is closed now. You can breathe, Bill. And we unfortunately found 0 disagreements. Very disappointing.
Yep.
Oh.
Yep. I'm sorry.
There are a couple of questions or, like, points, topics that we sort of covered already. So I'm gonna skip, like, include system versus modules and stuff like that.
Mm-hmm.
Other languages often come with either standard library or just, generally speaking, a language with data structures, like a world full of data structures, hash maps and vector-like dynamic arrays and stuff like that. Now, everybody who programs C has their own like standard library layer with their own data structures, pretty much. Okay, is this a good thing or a bad thing? Now Ryan starts off.
It depends on your priorities, I guess I would say. Like, do you want how much of like the code written in this language do you want to be sort of translatable? Like how to what degree do you want people to be able to agree because they use the toolchain? To what degree do you want them to have to agree on different data structures? The answer to that is probably not like 0. Like the fact that there's nothing in the standard library in C is probably not the optimal thing. Like they probably should have standardized like length-based strings. Like there are things that are very simple that you would probably do. Odin seems to follow this as well. Like instead of having operator overloading, it just has a map data structure, just has strings, it has these concrete concepts that you concretely know people need to use. I think a conservative approach like that is pretty reasonable. But on the other hand, I tend to take the concern of the cursive Lisp, if you will, a little bit less seriously than other people. So I'm okay with me having my own code base. Like, I need my own code base anyways at some point. If it doesn't include certain data structures, that's great. At least if they're not assuming too much. Like, if these are data structures that are very complicated, that are making very specific trade-off decisions that do not apply to my case, for example, I'm not sure what the utility of that would be. But so basically what I would say is that if you were to go back and design C from first principles, you would include more in the standard library than is in the C standard library for sure. But I don't think, but I think what people tend to want is the standard library should solve all their problems. And it's like, I'm sorry, but you still need a code base. So, and when you have long running code bases that exist for a very long period of time, you'll end up having one no matter what. And so I think that that's like a reasonable architecture actually for people to end up having. Not everything can be centralized in the language. But yeah, you would have more than C's standard library does. Like we've covered, the C standard library just kind of sucks. So
just to re-emphasize the point.
Yes, it's not great.
Bill.
If assuming it's proper C and we're not doing extensions, like I said, with slices, then yes, then you would have to have some nice data types. Like you'd have like a length-based string type would be good. Like just have that built in. But again, it's still going to be a bit finicky to use. But at least if it's standardized, it's nice. The thing about this just goes back to the idiom thing. Is in the case of Ryan, like so Ryan doesn't have that problem issue. But the thing is, he's got a product rather than a library. Like you've got an entire self-contained thing, which doesn't need the rest of the world does not need to interact with, right?
Right.
But if you're making libraries for people, you need to interact with everybody. So you need some common conventions that people use. So if you actually had a built-in string type, an array, like let's say a slice type, and let's say a dynamic array as well, if you had all those built in and use those conventions, then it'd be great, wonderful. Like you've got the same like style across all of the things, which is helpful language. But C is this weird oddity where if even in how C works now, you're gonna get issues. Because again, it's you've got this generic dynamic array. It's like, you're right, but C doesn't have generics. So you could have this macro approach, but it's not going to work very nicely. And it's like, there's no nice way around this. Like, this is the point. Vanilla C is going to struggle. The best you're getting out of all of this is just a string type. That is pretty much the only like data structure that I would think could be there. Also, the other one I'd probably say that you could do in there is a generic linked list, it's kind of like the Linux kernel-based linked list where you just have basic pointers for the things, and then you have to do the container of macro to get the actual like parent thing from. So that's about the only data structures I think would work in actual C that you could get. Everything else, you would have to extend C to do it to make it nice, unfortunately, if you're just talking about just data structures.
This is probably a point of disagreement, I would say, because I think that not to say it was intentional, but the conservative design of C's standard library having fewer standardized data structures to me, pushes APIs to it adds incentive pressure to APIs to be simpler with respect to what they're actually allocating and what types they're introducing into the system. So it's like,
Yep.
like C libraries, one of the properties you'll find more in C than in other languages is that people are writing APIs that are like, oh, we don't allocate it all for you. Like, you have to pass us the resources, you control all of that. We're just doing the simplest boiled down version of this transform that our library could provide for you. I think that that's a positive incentive to apply. So I think that the conservatism approach inside the standard library with respect to like introducing lots of standardized types that people standardize on, I think that's probably to some benefit. I agree with you on length-based strings though. Like that should be a thing. If you had a slices feature, that would be better. I'm not sure if I would want dynamic arrays standardized even, because again, that gets into allocations and things like this. But
No, this is where things get a bit weird. Yeah, because you got the problem is you'd have to have a standard allocator type as well.
Yeah.
And this is the problem. Like, I know this is probably where we slightly disagree, but we don't disagree. I think we're actually, it's kind of a thing. Yeah, I'm trying to help you here, Wookash. But like Odin has like a built-in allocator type, right? Because this came from when I was writing my C code. I had my own allocator type and it worked quite well. The whole point of the allocator type is it's a generic way of doing like a general allocator, because I'd argue that most people don't need custom allocators either. And when they do, they kind of just want to have like, oh, I want a tracking allocator. So I just want to override the current heap allocator. Ryan, on the other hand, and technically myself, we just use arenas everywhere where we can. So we don't even need the allocator interface. We just have an arena interface, effectively, and we pass around arenas everywhere. However, the problem is, this is the problem with a language design, is most people don't do that style of allocations. So if people still default to the malloc freestyle approach, you need this generic interface that can allow you to swap that out. So in the core library, if you're on the library for C, if you need to do allocations, you would have to have this general thing. However, if I was designing the C standard library, which is now going like 5 questions back now, like I would just say, hey, there'll be some basic allocation things, effectively virtual memory, maybe a heap allocator, but it's not global. And then every other function you have, none of them ever allocate. They all just say, here's a buffer, you pass in the buffer. And that's it. Or if you pass nils to it, or null pointer or whatever it's called, it'll tell you how much to allocate, like Win32 APIs do, and then you can pass the buffer to it. So you have this pretty much nothing ever allocates. So you don't even need to worry about the allocation interface, which is the same with the dynamic array thing. You don't even need the dynamic array in the standard library, as if every API was designed that way, not to need it.
So this is why I think the arena would be a useful concept to standardize in the standard API, because the arena is a slightly more flexible version of a buffer where it's basically all pre-allocated for the most part. Like, you can configure it always to be pre-allocation, period. But the API of it allows for either chaining or contiguous growth, depending on how you want to set it up. And so it's basically like the simplest version of allocation that you could imagine having in an API. And so I think for that reason, it's one useful building block on top of just a raw buffer that I think is, at least in designing code-based APIs, I've found to be extremely useful and widely applicable. So I think that is a likely candidate. I mean, it's in my base layer. I think it's a likely candidate for the standard library, because my base layers and my code bases, they're kind of what I would imagine would be in a standard library, if that makes sense. So yeah.
So again, mostly agreement, slight disagreement, but
you're happy there. We got a slight bit. I hope you're happy.
Honestly,
with that.
not satisfying enough, But okay.
Yeah.
Okay. Now, I'm gonna skip most of my remaining questions. I'm gonna do the last one, but I'm gonna say, in the meantime, I've been posting the Q&A link, and there are a couple of questions in there. So I didn't really review them, but let's go. We have like 20 minutes, so we're gonna have like last question from me,
okay,
and then we're gonna do 1 or 2 questions, the most upvoted ones. So if you're in the chat and you want to see a question, there's now like question battle under the link I posted.
Oh, you got your disagreement.
What?
That is where the controversy for this episode was. It was in the comment section.
Yes, the comments are the ones that disagreeing with us.
No. The main point here is this disagreement between you. Like, that's the whole deal. Anyway, okay, last question from me. Where would you learn C? Like, where would you go to learn C? Where would you learn it from? Today, 10 years after Handmade Hero, where would you learn it from?
So I can't say Handmade Hero.
You can.
Oh, I did. There you go. There's my answer.
All right.
I didn't learn C from Handmade Hero. I knew C before, but it was very much like that approach to writing C, I think, is still one of the better ones to learn from, because all of the other resources out there are bad. Again, they're not bad. They're just teaching you, like, let's say it's the malloc-free approach if you do an allocation, right? Which is, it's fine to know how other people do it, but it's not a good way of writing C. So it's kind of there's just not many good resources. This is half the problem. It's all in people's minds and brains and stuff.
So Handmade Hero, are there any other? Or is it like desert out there?
I don't know.
Ryan.
Yeah, I'm once again sorry.
There is a blog, Digital Grove. Digital Grove.
I don't teach. I don't know if I teach.
Couple of nice.
Yeah, it might teach you something. I don't know if it's going to teach you C programming, but you know, I try to put out what the stuff that I feel like I've learned. But Handmade Hero is my answer. Sorry to agree with Bill again and everything. Wookash,
yeah, but we feel like that's where we sparked from anyway. That's how we know each other, obviously.
Yeah,
but it's also like, I don't know. This is the problem. Is I'm always bad at giving resources. When people say, "Well, what's a good book on X or Y and Z?" I'm like, I don't know, because that's not how I learnt.
Yep.
And I can't tell you how I learnt because it was all over the place.
Yeah.
Was it? How much was it from people at your like work or group or university? Like, how much from other people compared to how much from like books and resources?
I would say none from other people for me, unless you count Casey. Like, unless you, well, okay, no, not true. I had a big leap forward when I worked first in the 4-coder code base, and then I worked with Alan. I learned a lot about how to properly write C in that time period. That is probably the biggest leap forward I've had because I've worked with alongside other people. But the vast majority of people in college or workplaces, I don't think they're really writing the best C either, so it's not going to teach you very much for the most part. Like, Handmade Hero was a really unique thing because it's like, Casey's such an excellent programmer and he's such an excellent communicator and you get to sit there and follow line by line as he explains and does all these things. And then at the end, like whenever you decide to stop, you've got a starting point for a project. That's a huge resource. Like there's just nothing really that beats it so far.
And he was asking the question about resources, or is it people resources? Technically, I would say resources, because the people I've like in real life, I've not known many programmers in real life. Most of the program I did was always like solitary. And then when I did do programming, either say, I did technically do programming at university, but it was a single course and I passed it with flying colors because I already knew how to program. It was not like this was an introduction for like physicists learning how to use MATLAB. And I think on that course, I got 98 over 100. And the only reason I couldn't go 100 is they marked me down for not using enough comments. That was it.
And they were probably wrong about it.
It doesn't matter.
It's a badge of honor. Badge of honor.
It doesn't matter. They weren't going to give me 100. That wasn't the problem. But regardless of that, I think there are people I've learnt loads from, but it's a lot of it's come after Handmade Hero is the best way of putting it. But the people I've learnt from is just like reading their source code. Like one of my favorites to always point to is Sean Barrett. And again, this STB libraries. And again, I know you did the wonderful talk. It took me ages to watch that thing with Sean Barrett. But Sean Barrett is one of those other people I would say thank you a lot to. He actually is kind of my impetus for making Odin as well. Because one of his famous things was like, how does he program in C effectively? And what he kind of showed to me that most of these higher level languages just have better libraries. Pretty much, and it's not not languages per se. It's the ecosystem. It's the mountain, as we're calling it, that gets you off there. And once that clicked to me, I went, "Oh my goodness, he's right." And that actually tells me that okay, all of this language things people are doing, they haven't actually done much. And C is still productive. Like, unironically, as long as you've got a really good core library for C, you can be stupidly productive in it. In fact, you can be more productive than some people using these higher level languages like Python or Ruby or whatever. And I remember that talk, and it was kind of part of the reason why I made Odin in the first place was because of it, which sounds about weird, like, oh, you can make C more productive. But it's like, no. I realized that, yes, I can get there, but I'm like, to get even more productive, then I'm going to have to start somewhere else and do it from there. So again, it's reading the code like STB library has been brilliant, and I learned loads from them, loads from Casey, but it's like, it's the code I've read from, and not necessarily books, like actual written books. None of them have been helpful to be really good at anything. Like Etsy, I mean, specifically. It's just been reading loads of different bits of code from randomly on the internet, I'll be honest with you. And that's because I lived my life on the internet. I'm of that generation. Like, I grew up on the internet. I still am. I don't know a time before the internet.
All right. Thank you so much for this round of questions. Now, a little bit of breathing room. We're going to head towards the community questions, and I have no idea what's in there. So it might be great. No. It might be terrible.
This might be wonderful.
You said take a breath. I feel like I'm losing breath as you say this.
Would Odin ever hit a tipping point where Ryan could see it to be the more obvious choice for him over C?
I
think that's the question for Ryan.
Yeah, I think so. I think long term, a bunch of things would have to happen in a certain way. So one of the reasons why, like, I would not build Odin, whereas Bill decided to, the reason why I would not go and build Odin if it didn't exist, for example, or my version of Odin, I wouldn't have made all the same decisions or whatever, but I think that there's much greater opportunity if you're going to do this big ecosystem, like build and rewrite kind of thing. I think there's more opportunity than building a new textual language. So I don't know if I would have gone and done that. So if nobody does that successfully in the next like 30 years or something like that, and it's just, or maybe not 30, maybe that's a little bit too much, but 10, 20 years, if there's no like big leaps forward in programming tooling, and really we're just stuck with the same textual languages we've been working with or something like that, and Odin has matured like dramatically in that time, including what I would say is like there's got to be like LLVM's got to go, there's got to be probably like, I don't know if I really care if there are multiple compiler implementations, but the compiler implementation has to be like small and reasonable, which I'm sure it is, but LLVM's got to go to really have the entire accounting. And I feel like there'd have to be a lot of investment into the project. But if it actually got there, and then if another thing happened, which is that C has continued to spiral into insanity, and the tool chains have rotted much more and things like that, then I think there's a pretty good argument at some point that you would just want to either move a code base to something like Odin or start a new one. Depends on where you are with projects and everything, obviously. But yeah, I think that's kind of what would have to happen. Like I said, I think there are bigger wins to do. If you're going to do a ecosystem scrap, I think there's bigger things you could do to make it an even better programming environment than just replacing the compiler. But if that never happens, if I'm wrong about that, and if Odin just like completely like beats everyone and it becomes very it becomes very mature, very good tool chain, very small tool chain, like, then I'd be like, yeah, then it becomes a much more sane option to build a code base in, I would say. But yeah, varies a lot. Odin, I would say, just like by far out of the newer languages, I would say, like if I look at Rust or Zig or any of these other things, like Odin is by far the one that is closest to actually meeting this, by the way. Like,
oh, thank you.
All of the other languages are trying too hard to add, like they're adding too much stuff, whereas Bill has been very good about being very like conservative about like, no, literally what is the actual language problem I'm solving? Let me solve it in a sensible way. And everyone else has just piling. So I would say that, that'd awesome. Be my answer.
Okay.
Next question is for you, Bill.
Okay.
If Bill ever had to stop working on the Odin language, would this spell doom for it? Would he be able to pass it on to the community?
So if you asked that about a couple of years ago, then it would have been Doom, yes. But now it's probably not, because the language is mostly done, as I keep saying. Like when I say mostly done, like the language itself is done. I will say there's some minor things here and there, like I'm adding just in case, but like they're so minor, even if I didn't do them, it wouldn't matter. But passing it on to the community is you don't let it random. You have a select, literally a few people that you trust to give it to, and that's it. Right? You don't want a free-for-all. You don't want a massive committee. You effectively need like 4 people that you trust to make the decisions, and that's it. And I say 4, I mean, they probably do different things. Like even on like the team now for Odin, we've got people who are working on certain aspects of the libraries. Sometimes they work on the compiler. Sometimes they work on just general bug fixes or anything like that. It depends on what they're doing. But they're not like having like, oh, I've got a great new idea, I need to put this in. As they already know, they just have to remember my words of wisdom to everybody. No. But that's kind of the thing. Most, like Odin, as I said, we've not got really adding new features. And if we're adding them, they're so tiny, you wouldn't have even noticed they weren't added, kind of thing. Like they're just like, oh, we're trying to solve this particular edge case, which we need a new intrinsic for or something stupid. That's it. Like, oh, you need to add new intrinsic. Yeah, go ahead, fine. But be careful. Make sure it is good.
You personally are confident in the Odin's future.
I am now, yes. It's taken 9 years to get to that point, but yes. Again, if you asked me like 3 years ago, maybe not. But now, yeah, definitely.
Great to hear that. Awesome.
As am I. I'm surprised.
What are the great C code bases? Rat debugger. Woo!
Yeah, number 1. Let's go. No.
Number one, yeah.
Ryan, would you recommend people learning C, learning from your source code, or it's tricky?
You know, I would say that there are things that we haven't, like, there are things about, like, there are problems inside of the RAD debugger codebase that I'm not sure are solved in the best possible way, like asynchronous programming. I'm not sure my version of that is the best version. Well, I'm definitely sure that it's not the best version possible, but it's I don't even know if it's structurally what you want exactly. So I'm not sure if I would recommend that people go learn multi-threading, for example, from the RAD debugger codebase. But I think I'm proud of the codebase. I think me and Nick and formerly Alan did a lot of good work in it, and I think we've been, I think, more disciplined than most C codebases are. Like we try to be really good about like always having a good story about allocation, always having a good story about strings, really tightening things up. We're pretty good about that, actually, compared to most C code bases I've looked at. So I would recommend it maybe, but obviously I'm biased because I literally have written a bunch of it. So another good code base would be Quake 2. Like people go look at the old id Software code bases. Those are all great.
I wouldn't recommend Doom 3 personally because that's weird C++. Even John Carmack disagreed with.
Yeah,
the things I have to understand, this is a caveat. Carmack, in each version when he was doing Doom or the Quake stuff, he was trying a new style of programming out every single time, effectively. Right. So you can actually see how different the styles are, even though they're all written by Carmack. They're all very different. Like Doom 3 is very much, he went through a noob phase to do all this, to see how it worked.
Yep.
And then the Quake 2 is very, very like what we'd call old-fashioned C.
Mm-hmm.
So if you compare all those different ones together, you can see a different style. But yeah, they are nice to see how, like, not say the best in their styles, but like you can learn a lot from Carmack. Doing that stuff. Yeah, that's good. That was just a caveat to add on. Carry on, Ryan. Anyway.
Yeah. Well, yeah. The only one I've actually spent a lot of time looking at was Quake 2, and I agree. It's very old school C, but it's not like the kind of old school C where people are like just arbitrarily allocating everywhere, like tons of clever little loops where 30 things are being mutated in like 3 expressions, and you're like, what is going? It's really not like that. It's like very straightforward like grounded, like down to earth kind of C programming where you've just got a bunch of static arrays. People are just doing things on these arrays. It's pretty straightforward, and there's some good like organizational or architectural ideas in it that I think are pretty good. So that's the one I've spent most time with. I'm sure you can learn a lot from the other ones too. Sounds like Doom 3. I know, yeah. Like
it's the Upier of the both, but the code's still fine. Like it's still readable. If you know what I mean.
Yeah.
It's so hard to find because also it's C++ obviously. But I don't know what to answer this question because I don't know. It's also one of those things where I just don't think this way. I've gathered so many things from different places. Yeah. Where I'm like, I don't really categorize them as, oh, this is my best resource. It's like, no, I've learned loads of lessons from this. I learned loads of lessons from this and this and this. Yep. So I hate, I'm not being rude. People always ask this thing. I don't know how to answer these because I don't think this way.
You brought up Handmade Hero as a learning resource. Yeah. I think it's good to mention that on handmadehero.org, you can buy the source code for $15. So you can get...
Yeah, that is cheap. That is very cheap. And you can learn a hell of a lot because it's got all the version control on it as well. And you can see it, and it's a very clean, easy way to read. And you could probably learn a very good way of doing C-style programming.
Mm-hmm. Okay, I'm going to do one last question that is not like from the top, but it's very interesting. It's almost philosophical. So you got... Every one of you gets the turn for the question. What's the most dangerous misconception young developers have about C? Bill.
I don't know. I guess if you're saying young developers, I guess most of them saying either manual memory management's hard or pointers are scary or whatever the common tropes are. Stuff like this. But is it dangerous though? Those are kind of misconceptions though. They are, but they're not. It's hard to. Oh, Ryan, can you answer?
Yeah, I think I've got an idea here, which is like it has to do with people. It's less important than people think, and I think than people are taught. It's less important. It's less important than people think that the compiler does certain things for you, and that the standard library does things for you. When it comes to like for example, one thing that people will bring up, one thing that's been like I don't know over the past couple of years is like, oh, I really need pound embed. Like I need to bake some file into my program. So what I'd really want to do, because it's like an asset file that I don't want to load from disk. Like I want to just send this executable to people, and then they start the executable. It's a game. It's got graphics that come from an asset. So I want to bake that asset into the executable. And everyone's like, man, I really just need like a pound embed preprocessor feature where I can say pound embed, and then I put the path of the thing, and then it's like, it's just a C array secretly in my source code that I can refer to with some identifier or whatever. It's like, this goes for memory management, this goes for the pound embed thing, this goes for strings, this goes for all of those things. Like, don't mistake a language and compiler problem for an API problem. And if you know how to program, you know how to specify some text that says embed this file, and then to generate some C text, which defines that array. Or, you could even go hardcore with it and say, oh, it defines an object file that you link with or something like that contains the binary, so you don't have to do like this ridiculous like textual generation. You know how to do that. That's a very simple problem, actually. And if you know how to do that, then you know how to implement pound embed for yourself. Like, you just know how to do that. Same thing with strings. If you know how to build a code base, you don't have to be beholden to the way that people have written C in the past. And so, I don't know, it's come up a lot in this discussion, but it's like, don't think you have to rely on the compiler developer to do something for you to be able to do something comfortably, and don't mistake language design problems with API design problems. And if it's an API design problem, you're in a good situation, because that means you can build your own API that actually solves it the way you want it solved. So that's what I would say.
There was another thing I wanted to add, because I thought you were going to go a different place than this, but this is actually good. The other thing is that a lot of beginners think that the compiler is also magical, and they think it can solve a lot more than it actually does.
Yeah.
It's one of those things, yeah, but this will optimize it out. The compiler optimizes out for me. It's like, don't ever make this assumption because it's probably wrong. The only people who can make that assumption are people who know how the compiler actually works. And you don't know if you're a young developer. And that's fine. But you can learn from experience and doing it. But like, don't make these assumptions. Like, it's the same people when they do C++. Well, there's zero cost abstractions, don't you know, in C++? I know that's not C, but like I'm doing this on purpose as an example. And it's like, first off, if you look at the developer, like the debug builds, the development builds, they are extremely costly. They aren't very well. What they're talking about is in optimized builds, firstly. And secondly, there is a cost because you're assuming that this style of programming has no extra cost to it, but it might have loads of cost. So you have to understand is like, okay, how do you think this is going to get transformed to the machine? And if the answer is you don't know, then don't assume it's going to be magical then, is what you're hoping. So it's not going to happen. So I'd say there's probably the biggest dangerous aspects, assuming the compiler is magical when it's not.
Awesome. Gentlemen, thank you so much for the bloodbath that we had. It was awesome.
I've never agreed so hard with a gladiator.
Yeah, this is so annoying. Oh, I hate that I agree with someone.
All right, can we do the shout out first? Ryan, where can people follow your work? Where can people follow you?
So I'm just on Twitter as Ryan J Fleury. Fleury is spelled Fleury. Everyone likes to put the U in front of the E for some reason, so I spell it out every time.
Fleury.
But yeah. Fleury. So Ryan J Fleury on Twitter. rfleury.com for my Substack. And yeah, I mean, if you want to look at what I tend to work on, you can go check out the Rad Debugger. Which you can just search for it and you'll find it.
rfleury.com, but your blog is called Digital Grove.
Yes.
Which is a bit confusing, but still works.
It is. Okay. It is. I could fix it. The Digital Grove name came later, so I should probably change the URL at some point.
Because there was also another name before that, but you had to change it as well. So yeah, all confusing.
Yep. And there was another name before that. It's been a whole thing.
Do you own the domain Digital Grove something?
I don't want to say this publicly because someone's going to go buy it from under me if I say no.
Smart.
But I probably...
Yeah, let me just go...
Yeah, domains...
Okay, Bill, while Ryan is
if you want to find me... if you want to find me on Twitter, I am @thegingerbill. If you're going to find me on GitHub, it's just Gingerbill. If you're on YouTube, it is Ginger Games, but you can find it through Gingerbill, no problem. What else is there? You can also find my projects. It's the Odin program language is one of them. And then all the other stuff I do for work, which is at Django Effects. So Django is JANGAFX. Because people mistype that as well, by the way. So that's where you can find me and all the stuff and all what I'm working on. And also the Discord as well for Odin. That's a very, very popular thing. All the forums, or just type in Gingerbill. You'll probably find me or that American comedian. So yeah,
I don't know. I've never heard of this.
If you type in, you'll either find me or this American comedian is called Ginger Billy.
Oh, Ginger Billy! Wow.
Yeah. There you go.
He looks like a very angry version of you.
Yeah, angry American version of me. Yes, with a much bigger beard and much bulkier muscles. So yeah, there we go.
I would definitely recommend following both Gingerbill for hot takes on Twitter. And Django FX for cool ass videos.
Yeah.
Like these visualizations are awesome. Awesome.
It's amazing.
We are trying our best for the visual effects industry, for games and film industry and such. We are literally trying to make tools that are actually just fun to use as well. Not just fast and real time, but fun. Because I think that's one thing people forget is we make software for other people. It's not just for ourselves usually. And you kind of actually want to enjoy using it. You don't want to be pulling out your hair, or lack of it, in my case. Because the amount of times I just get annoyed, even at like the web browser I'm using each day. I don't want that experience with us if I can help it. So there you go.
All right. And both of these gentlemen have done the talks at BSC. So you can check out both Gingerbill's and Ryan Fleury's talks. on YouTube.
Yes.
And with that, I will be also thanking everybody who tuned in, the audience who was there.
Cool.
So thank you, everyone, and hopefully see you some other time.
Okay. Thank you very much for having us on, Wookash.
Thank you.